Good morning, everyone. Welcome back on this third day of the inquiry. We're now moving on to the Ministry of Defence's evidence, and it's intended that we'll cover that for the whole of today. We may finish today, which means we may not need tomorrow, but we'll see how we get on, and we'll plan some breaks throughout the day as we go forward. Ms. Crawford, do you want to introduce your witness, Dr. Bowers, please?
There is just one
apologies.
Preliminary matter from us. And that is, you will recall yesterday in the cross-examination of Mr. Thompson that he made a concession in relation to the wording of the condition, and that was in consultation with the MOD, you might recall at that point. So we'd like you to have, or all parties to have, a final suggested draft condition, and we can get that to you, but I wonder whether or not that should wait until we've had the evidence from the MOD witnesses on policy and conditions. So there may be things coming out of that as well, that at the end of the day, we've got a printer, everybody goes away with what we're suggesting. So we could either do it now or at the end of the day, but my suggestion is it's better after we've had the debate.
Thank you, Mr. Hardy. It sounds like it might be sensible to get through the evidence of the Ministry of Defence today, which will no doubt touch on those matters, and then we can get that from you. Ms. Crawford, do you have anything you want to add?
Well, in relation to that, it would of course be helpful to see the revisal to the condition. It may be relevant to some of the evidence from Mr. Egan, but I think I just reserve my position. I would say also that I reserve my position as far as making any comments in submission regarding any revised condition. It's a bit difficult to comment on something I haven't seen.
So those points are understood. I mean, the concession yesterday is very simple. It's just addition of the words in consultation with the MOD. Now, if it would help my learned friend, I'm sure at lunchtime we can print it off or where we get to so that we've got a working version. What I could then say is the version perhaps that we formally submit to you as the draft comes at the end of the day after we've had the debate.
Does that sound reasonable?
It would be very helpful to see the working version at least.
Okay, if we can aim to have the working version of it by lunchtime, that will give the witnesses a chance to have a look at it and, if necessary, make some comments, and then there's further opportunity at the closing submission. Any further preliminary matters before we move on to Dr. Bowers' evidence? Okay, Ms. Crawford, thank you.
Thank you, and good morning. The first witness for the Ministry of Defence is Dr. David Bowers. Good morning, Dr. Bowers. Dr. Bowers, by way of introduction, first of all, you have provided for this inquiry a precognition, a summary of that precognition, an inquiry report, and a supplementary precognition. And I think you're also the co-author of two technical notes provided by an organisation known as AWE, the first from 2022, CD 14.046, and the second dating from this year, CD 14.080. And you co-authored those last two reports with your colleague, Dr. Selby, is that correct?
That's correct.
Dr. Bowers, in your precognition, your main precognition, I might describe it that way, by way of introduction, in Section 1, you introduce yourself by explaining that you're a seismologist with over 30 years' experience of research into the technologies that support the verification regime of the Comprehensive Nuclear Test Ban Treaty, with which we're now familiar, and that you've been the forensic science lead rather than forensic seismology at AWE for over 2 decades, and you refer to the technical note I've just asked you about. I wonder if, and you also in 1.2 tell us that you've been actively involved in scientific expert groups which are set up to advise the CDPT organisation based in Vienna. You've been a technical advisor since 2001 on the UK delegation to Working Group B of the CDPT organisation. Now, just pausing there, I wonder if you could also have a look, by way of introduction, at your CV, which has been lodged as CD 14.063. Just bear with me while I get it up on my screen. And I think this is rather than a formal CV, it's really a summary of your career to date. And we can see that you are the Fellow of the Geological Society of London, which you joined in 1990, and a member of the Seismological Society of America, which you joined in 1994.
That's correct.
And further information about your position in AWE, noting that you joined as a junior research fellow after studying for your PhD at the University of Edinburgh on methods for identifying earthquakes and underground explosions, co-sponsored by NERC MOD. NERC, what's NERC?
So it's the Natural Environment Research Council.
And then picking up on a matter which you refer to in 1.2 of your precognition, since 1998, you've been closely involved with scientific expert groups set up to advise on aspects of the development of the International Data Center of the Comprehensive Nuclear Test Ban Treaty Organization in Vienna. What's the International Data Center?
So we heard about the International Monitoring System, the network of stations. So data from those stations are sent via communication system, global communication system, to a data center which is based in Vienna, which is known as the International Data Center. So that center receives those data, archives them, and processes them to produce products. One of those key products is known as the Read Event Bulletin. So that's a bulletin of mainly seismic events, the vast majority of which are earthquakes. And the aim is that that bulletin will highlight any nuclear test explosion. So the main part is seismology, but also it would detect low frequency sound waves from atmospheric explosions and essentially sound in the water, hydroacoustic waves from underwater explosions.
And we have indeed heard evidence about the International Monitoring System, the IMS. Could you explain a bit, have you had involvement with that?
So with the International Monitoring System, the main role has been to analyze data from those stations. But AWE is also responsible for the operation of the Estonia seismometer array. I think the obligations for that will be spoken to by Mr. Laws. I have been involved in the design of at least one seismometer array that was new, that was built in 2002, 2003, which was in Niger, in West Africa. But in general, we have to keep a watching brief on the stations and the data.
Now, we've heard evidence that the stations comprise what are described as primary stations and auxiliary stations. And I think the array is designated, if that's the right word, as an auxiliary station. Professor Stiles, in his evidence to this inquiry, albeit he's unfortunately not been able to provide evidence speaking to his papers, may suggest that an auxiliary station is of less importance to the International Monitoring System. Would you agree with that?
No, I don't agree with that. The auxiliary seismic stations differ mainly from the primary stations in the way that they're funded. So primary stations operations are funded by the treaty organisation. The responsibility for funding and operating the auxiliary stations is with the host state. Other than that, they are to meet the same minimum specifications, and the data are processed the same way at the International Data Center.
And in general terms, are you aware about the effectiveness of the International Monitoring System in detecting nuclear test explosions?
Yes, that was right at the heart of my job, both in terms of what you might call specific areas of interest, such as you should probably imagine North Korea, and in general terms in explaining the
capabilities of the international monitoring system to policymakers and diplomats. And for that sense, I think in Professor Stiles' inquiry report, it talks about threshold monitoring and these maps of detection capability. So they are their main role. The purpose is to explain in general terms to the policymakers what it is their money is being spent on and what they're getting for their
money. Okay. Going back, if I may, to your CV, your abbreviated CV, you tell us that you took over the science lead for forensic seismology in 2000 with responsibility for 3 areas. We can read those for ourselves. And then after setting out those 3 areas, including, we see, technical advice to Her Majesty's Government, and you note the SDLMUIR working group about which we've heard something in this inquiry. You then say that since 2001 you've been a technical advisor on the UK delegation to Working Group B of the CTBTO. What work is done by Working Group B?
Okay, so in 1997, the United Nations established the Preparatory Commission for the CTBT organisation, and that Preparatory Commission has 2 working groups: Working Group A, which is legal and administration, and Working Group B, which deals with technical verification elements. So I'm essentially a waveform expert, so that's the seismic, the infrasound, and the hydroacoustic, but there are also other elements that are considered by Working Group B, which is radionuclides and atmospheric transport, and then the general data processing capabilities of the International Data Center, which I'm also been involved with.
And so far as Working Group B is concerned, you told us about its remit, as if I could call it that way. Do you perform a similar remit for the MOD in relation to the array?
So we, AWE are known as the design authority for the array. So part of this is to make sure that the array meets the minimum requirements and provides a high data availability to the International Data Center in Vienna. A part of the station operation is subcontracted to Grow Up Systems Limited. But the design authority and the data availability and the use of the data, processing it a bit to analyze specific events, which I think was the Nord Stream event, is shown in my inquiry report, is the responsibility of AWE, where we run what is known as the National Data Center.
Okay. One point I'd like to pick up with you before going on to look at matters of more detail. Again, it relates to Professor Stiles' reports and evidence, and he states that the CTBT organisation approved the threshold and the budget which the United Kingdom government decided, no doubt through the advices of AWE, to set for the array. Was there that formal approval? You need to put your microphone on.
So at Working Group B25, Professor Stiles gave a presentation to what was called the Science and Technology Task Group, which listened to talks and presentations from scientists and engineers and researchers, and it was presented in a form so that diplomats could have access to the latest kind of research. So that was presented to what we call the big room, but the tradition with that task was that it would be essentially recognized that presentation had been given, but it was never, that those topics were never formally discussed, and therefore would not form part of recommendations from Working Group B to the Preparatory Commission.
Thank you. I should have just picked up one further point from your CV, if I may. You tell us that you've published over 35 papers in peer-reviewed international journals, and I think you then list them at the remainder of your CV. Is that correct?
That's correct.
Okay, thank you. We probably don't need to have your CV in front of us any longer. You mentioned in your introduction your preparation of various recognitions, reports, and technical notes. Those contain, I think it's fair to say, a fair amount of somewhat diffuse detail, which may be difficult for the layperson to understand. So what I propose to do with you, if I may, Dr. Bowers, is to pick up some topics, hopefully to help explain matters to the reporter and indicate where there are lines of disagreement between the MOD and the applicant. And the first topic I'd like to pick up with you, well, I should say before I look at those topics, so far as your technical notes are concerned, and we'll come on to look at those in a bit more detail. From what you've heard in this inquiry on behalf of the applicant, has anything been said to give rise to doubt in your mind that what you've reported in those technical notes is inaccurate or incorrect?
No, ma'am.
So do you adopt those reports as well as your recognitions?
I do.
Going back to the first topic, if I may, which I'd like you to discuss with the inquiry, that's the topic of threshold, about which we've heard much in the course of this inquiry, both Tuesday and to a little lesser extent yesterday. And we know that it was set at 0.336 nanometers. But taking a step back, knowing what the number is, the value is, what is the threshold? Can you explain what that's meant to tell us?
So in the algorithm, as it's currently set out, the threshold, which is effectively the limit at which cumulative seismic ground vibration from wind turbines, which should not exceed that, has been set relative to some baseline. And that baseline was chosen back in 2005 to be the ambient background noise at Estonia at normally windy times, and I can explain.
Okay, please do.
That's so I'd need to go to CD 170-2007.
That's a report by Elliott et al.
Yes. So back in 2004, I guess there was the Estonia working group asked Professor Stiles and I guess myself, a group, to try to firstly identify whether wind turbines would be an issue for the array, and then after we'd achieved that and we'd concluded that it was seismic vibrations from the wind turbines that were causing the problem rather than this infrasound low frequency noise coupling to seismometers. We were then asked to come up with some way of safeguarding the array, or at least quantifying what the problem was. So we had a guess that we would need to know how noisy Castleweary is at the higher frequencies. So previously a study had been done in 1997 as part of preparation for the CTBT and the International Data Center, which had looked at data of 1 Hertz, and that's a report that's in the inquiry documents by Bill Shaw. But we realized we'd need to go to higher frequencies. So a summer student and I worked on 1 month of data in February 2004, and that analysis is summarized in this. I'm afraid it's still a draft report. I never got round to read it on this, but I guess the key figure is figure 33. We looked at figure 32 earlier.
You might just want to wait while we catch up with you.
Okay.
33 is on page 26, I think. 27, actually.
Okay. So what we're looking at here on the horizontal axis is the wind speed, which was measured at the meteorological station at the observatory, which is down in the valley, just northwest of the village. Whereas the array is up the hill across 10 kilometres to the northeast, the meteorological station. So at quite different heights. And the vertical axis is showing the root mean square of the amplitude in the 1.5 to 4.5 hertz passband, and each dot represents the average root mean square amplitude of all of the 20 channels in the array. So the array has 20 seismometers, we've averaged the power spectra, and then integrated the area under those power spectral curves to mean square, and then taking the square root. And then there is an attempt to draw a line through those dots. It's a progression, and there's confidence when it is expressed. Now, what is clear is that even when the wind speed is 0, there's still noise, considerable amount of noise at the array. And as we increase with noise, with wind speed, those dots appear to flatten up. You get above sort of 6 meters a second, 5 meters a second, and it looks like a straight flat line. So at this point, our original aim, which was to try to think, well, is there a relationship between RMS and wind speed? It didn't look very promising. It looked like it's flat. So in the end, I took the population of those dots, whether it was above about 5 meters a second wind speed, and I took the median mean square. And the median was 0.336 nanometers. That's where that comes from.
So this report explains where the 0.336 nanometers figure comes from. We've heard something about the wind speed at the array may not have been calculated correctly, or may require to be, and I'll come on to develop this with you, look at it in perhaps greater detail later on, but we've heard something about it requires to be a recalculation of wind speed. What's your comments in relation to that, having regard to the threshold? What's the relevance of recalculating wind speed for the purposes of the algorithm?
So the key point is that the threshold is related to P noise equals P the threshold, power of the threshold. But the power of the threshold is calculated from the seismic ground vibration of wind turbines. So it's the wind speed where the wind turbines are that matters. Now, there may well be a relationship between the wind speed at the array and the wind speed where the turbines are, but we have not established yet what that is, and that was highlighted as further work in section 6 of the SIDE 2014 report, which is CD 14004.
So as regards whether the algorithm may or may not require revision on the part of the MOD. What is your response to the suggestion, I think it's from Professor Tuckwell, that we need to investigate the wind speed at the array?
So that's part of the solution. But we also need to investigate the wind speed where the wind turbines are, and given the safeguarding algorithm is for the whole of the consultation zone, we need to understand the relationship between the wind speed, the seismic noise at Estonia, and the wind speed where the turbines are. And for that, we need to understand the variation with distance on the array of the wind at, I guess, the reference of height of 80 meters for the wind turbine. And the current algorithm has the reference wind speed of 12 meters a second, which is when the turbines considered back in 2014 were reaching rated power. They were generating maximum electrical power. Now, there was a study done in 2014, and Zai, in their 2014 report, highlight that study could be repurposed to answer this question of the length scale, the wind speed variation relative to the array. They also point out, I think, showing great insight, that actually the turbines closest to the array are the ones that have the highest impact. And so it's the wind speed where those turbines are that needs to be driven more weight, and that clearly requires some thought and further work.
Thank you, Dr. Bowers. Second broad heading, and I think the phrases or terms, rather, threshold and budget are sometimes used interchangeably, but we've heard something primarily from in Professor Stalz's evidence in relation to that being set at x equals 1, so that we double the 0.336 figure at the array. What do you know what the basis was for setting it at x as 1?
So firstly, if I can clarify that the doubling is of power vibration, not of the 0.326. So you need to square. That's okay. It's not obvious to non-physicists. So yeah, you need to double the power, and the criteria for that comes from discussions with Professor Stiles back in 2004, and it was deemed that would be his proposal, and that was to try to balance the conflict between two reasonable things. One is the detection capability of the array under the Lisbon Treaty and the UK government's obligations under that, and the other, which is to generate electricity using wind turbines, the vibration. So it was set that the power, we would accept as much power as we had in the ambient noise measurements that we made in 2004. And then the question was raised, well, what does that mean in terms of detection capability? And we tried to illustrate this, and that is in Stiles' 2005 report. So if we go to CD 14002,
just allow us to catch up with you.
Yeah, sorry. So it's at page 82. So under question 10, you'll see an equation which is sigma w squared equals x times sigma n squared. So in this case, sigma w squared is the SGV power, the SGV, and sigma n is P naught. And then we have some equation, and we relate the very crude relationship that's not exact in any way, but we have a relationship to yield that you could detect at a specific test site, which is the Soviet test site in Kazakhstan. So that's W0. And then the yield that you would be able to detect if the SGV power was added to the 100 meg power. And it turns out that it would reduce the detection, or increase the yield that you'll be able to detect by a factor of 1.6. It's just a relative term as an illustration of the effect at a specific test site. If you move to different test sites, different noise conditions, different stations, different answers. But it's just to demonstrate the effect.
This may be too simplistic, as I'm sure you'll be the first to tell me, but if you reduce or increase the denominator x, that will have a consequent effect on the ability to detect explosions. Would that be correct?
Yeah, any increase in x will adversely affect the detection capability of the array.
Thank you. The third topic I'd like to explore with you is the algorithm, and I just want to deal with one broad parameter of that at present, and we'll go on to look at the detail shortly. But we've heard about the propagation term, which is the product of Q and V. If one were to contemplate changing QV, what impact, if any, would that have on the source terms?
Okay, so I think probably the best way to show this is to look at the Design Engineering 2014 report. So that's CD 14004. And if we can go to page 19. Okay, so this is a map of Clyde Wind Farm, which at the time had 152 turbines, since been extended. And so those are the yellow circles across it. The red dots are seismometers that were deployed. I can't remember, but the focus was on the furthest of those red dots, which was 4443. Now, the source term in the algorithm is based on a single turbine at 1 kilometer distance, the vibration that would be received there. Now, as we can see, there's 152 turbines at various distances. So the closer the turbine to that seismometer, the more vibration contribution is going to be observed, and the further away the turbines will be, the fewer, the lesser contribution to vibration. And that proportion will depend on the propagation term, which is controlled mainly by the product of Q and V. So do the calculations in the recognition. So if QV is 100, then that seismometer effectively sees about 18.9 turbine. So to estimate the source term, we measure the seismic ground vibration at power spectral density at the seismometer at different wind speeds, and then we divide by 18.9 to get the source term for the type of turbine that Clyde exceeds 2.3. Now,
can I just pause there?
Yeah.
Power spectral density, I don't think we've heard that term. Could you explain, please?
I will have to go to the.
Okay, well, shall we park that and
I'll come back to it. Yeah, is that okay? So let's just say there's a curve, we divide it by 18.9. Now, if Q is 10 instead of 50, then the turbines that are further away, the signal is reduced relative to Q is 50. And it turns out that if Q equals 10, then that seismometer effectively sees 6.3 turbine. So you see 6.3 turbine. Should probably check these numbers.
it is in the recognition?
Okay, right. So you would take this curve, which we're going to explain in a minute, and divide by 6.3. So it would be a larger source term by a factor of 3 in power.
In 12.11 of your recognition, I think, Dr. Barrett. .33.
Okay, so yeah. Okay, so that's why the source term. So I guess I need to go back a little bit and explain and correct it in this document. Okay, so if you go to figure 23 on page 37 of the same document. Figure 23, looks at copy page 37. So along the horizontal axis, we have frequency, and the vertical axis has what's called power spectral density, and it's relative to the ground displacement. So it's a log scale. So that means each one of those gains is to 100. And this is at a wind speed of 12 meters a second, and the cyan line is the seismometer that I was referring to earlier. 4440. If you follow the cyan line from the left, it decays, and then you see a bump around 1.5 hertz, and then around 2.1 hertz, and then another bump at 2.8 hertz, and so on. Now, if you wanted to know the mean square of the ground vibration, you would take the area under the curve, the sine curve, between 1.5 hertz and 4.5 hertz, and that would give you mean square of amplitude vibration at that station, at that seismometer. That's what was done for the array in the Elliott report. So we would take this this measurement and divide by the number of effective turbines that it sees, which QV equals 100, we would divide it by 18.9. And we would also correct, a very small correction, but we would correct for the distance, so we moved it from from 825 meters to a kilometer. And that was how we derived our source term for the 5 turbines.
So if you're going to alter the QV value, this PSI report tells us that you're going to have to revisit your source terms as well and recalculate effectively.
Yes, indeed, you'd need to recalculate the source term, especially for the wind farms where you measure where there's a large footprint.
With a large footprint.
The other smaller turbine wind farms in general, you're able to deploy the seismometers to measure the ground vibration, so the correction is relatively small. It's still needed, but it's relatively small.
And having regard to this application, and we know it's close distance to the array and the number of turbines over 40, 45, 47, if one were to change QV, what impact do you think that would have in the source terms?
So it would make the source term, well, if you made QV smaller, the source term would have to be larger, and getting that QV is higher, then the source term would be reduced.
All right. Professor Tuckwell, in his let me just get the reference, in Appendix A, in his recognition, I think it is. No, sorry. It's in his report, I beg your pardon, at APP 01002. On the last page, Appendix A starts a few pages before that, has a diagram at A10, or a graph at A10, which bears to plot the effect of changing QV. What, if any, comments do you have on this graph? And I'll allow you to catch up with me this time.
Yeah, so my understanding is that there's no correction for the source term in drawing this graph. So when you're close to Q of 50, it's probably a good reliable curve. But as you move to lower Q, so it's become more and more unreliable.
And in the context of this inquiry, does it have any value for the reporter in making recommendations regarding the likely possible impact of phosphide on the array?
I wouldn't advise using this curve to make that judgment.
We've heard something about levels of confidence and how that term is used in the scientific community, and I'll come on to discuss that later on. But from a scientific perspective, do you have any confidence in this graph?
So at the high end of Q, when Q is close to 50, it's probably a reasonable curve. It reflects that when Q equals 50, safeguarding algorithm for the tables that Professor Tuckwell has used, was produced in Appendix A. But as you move to lower Q, then no, there are two issues. One is the source term, which you discussed, and the other is the energy scaling that we use to move from the reference turbine.
Okay, that's another term I don't think we've heard. Is it convenient to address energy scaling at this time?
Okay, so if we can go back to the SCI 2014 report, so CD 14004, I need to go to 63.
And on page 76, I think.
Okay, so if we look at page 74, and the equation at the top, which looks a bit daunting, I'd imagine. So the challenge is to go from the turbines we have measured in 2014, where we had three types. There was a 660 kilowatt turbine at Dunlore. We had a 2.5 megawatt turbine at Craig Wind Farm, and we had these 152 Siemens turbines at Clyde, and they all had different heights and different rotor diameters, top heights and rotor diameters. And the challenge was to try to come up with a way in the safeguarding algorithm of including a general turbine type, because they have varying hub heights and rotor diameters. And the other challenge was to try to do this without changing the directive that the information an applicant would need to provide to the MOD. So they currently provide effectively the rotor diameter and the hub height. So the idea, the hypothesis, was that the energy in the wind, so that's the kinetic energy in the wind, which is proportional to the wind speed squared, and it's moving at the wind speed, so the energy available to the turbine rotor area goes as the cube of the wind speed, and the area goes as the diameter of the rotor. So the idea is that this energy that was available to the turbine to generate electrical power was a fixed proportion of that was going into the ground to generate seismic wave. So that was the hypothesis. So we jump ahead to figure 62 on page 75. So here you can see again our power spectral density, but this time it's for ground velocity, because the energy in a seismic wave is proportional to velocity squared. Different frequency, and we can see the three turbine types that we had at the time. Craig was in blue, Clyde was bigger, it was higher, with the 18 meter height and both diameter. It was bigger anyway, and red was Dunlore. And we're going to take the raw, so these are all our normalized source terms at various wind speeds and normalized to 1 kilometer. And then we scale each one of those traces, assuming a power of the the rotor diameter, and the wind speed. It's called the exponent. So above that is figure 61. And this was an amazing result, actually, my opinion. Is that the wind speed, and then you grid search for different exponents in rotor diameter and wind speed, and you find that the contours of a misfit occurs. And you find that the minimum is a wind exponent of 3, which is the wind speed, which was our hypothesis, and the exponent for the rotor area or diameter is 1, which was also fit our hypothesis. This was a good day. I have to acknowledge this was, I guess, the idea came from talking to Dr. Marmo at Zi Engineering, but it was Dr. Marmo who did the work. I'd love to take the credit for it. It's really good, but I really shouldn't. So then what we can see in figure 63 is what happens to the source terms once you apply that scaling, and it collapses down into a fairly flat source term. So this seems to fit. Now, the key here is this peak in the green curve at 2.8 Hertz, which is the Clyde part, and this is dominated, we think, by structural resonance, not blade part. That's too much detail. So if Q is 10, then that peak needs to be 3 times higher than it is in our model. And the question has to be asked whether this scaling would work if that peak was 3 times higher. And we haven't addressed that.
So, just trying to summarize your evidence there, and I'm sure you'll tell me if I've incorrectly summarized it. If you're going to change Q in the algorithm, you'll have to look at the source terms, and you'll also have to address the energy scaling issue as well.
I believe that is true. It's the algorithm as constructed by Zi. There's a lot of moving parts, and if you start messing with one of them, you have to think about the effect and the assumptions in the safeguarding algorithm that's being constructed that you might violate if you just pick one part.
I don't know if now is a convenient time in your evidence to pick up that term power spectral density, just to explain what that is to the reporter, or whether there's anything else you'd wish to look at, we should be looking at in the Zi 2014 report at this stage.
Probably.
Well, maybe, okay. Can we address power spectral density?
Well, I can go through the power spectral density again if it wasn't clear.
Is that what we've just been talking about?
So the time before.
Oh, time before. Sorry about my misunderstanding.
So the figure.
All right. Could I next look at in a bit more detail Q and its value? And could we first address the source of Q, which was input to the predictive algorithm in 2005? Could you explain to the reporter how that was derived? And for those who are keeping numbers of my chapters, I think this is chapter 4, looking at Q in some detail. think this might be by reference to Professor Stiles and indeed some work he might have carried out.
Yeah, so we need to go to document app.001.007. So this was a summary from 2004 of where I had got to report, an internal report, which was shared with Professor Stiles, and now with you. So I start off by explaining the array and how it works. I hope that's clear. That's in my definition. And then in figure 2, explain why in the summer student work we focused on 1.5 to 4.5 hertz because explosion signals are strong there. And then we do a literature review, and then section 5, which starts on page 16, and looked at the seismic signals from Jaguar aircraft crash, which was just off the end of the array in 1986. So in figure 12, which is on page 18, you can see in the top panel shows the recordings across the red channel, the red line of the array, and arriving at red 10 first, R10, moving out to R1. And where I've marked the vertical line is the infrasound signal. So this is the low frequency signal coupling with the seismometer. Now we know that this isn't important, but in 2004 it's considered important. But the earlier arrival, the largest arrival on the traces is the Rayleigh wave, seismic wave arriving. And we can use the amplitudes of those, as we've done in much more detail now, to estimate roughly the product QV, the quality factor, and the peak wave speed, and then we nominally assume that the peak speed was 2, so we've got a Q around 50, and it's from these data here, that the personal communication arises that is referenced in Professor Stiles' 2005 report to Q being 50, in addition to the reference to the Macbeth and Burton paper from 1987. Now, in CD 14073,
that's the Stiles,
yeah,
2005.
No, this is the
I'm sorry.
recommendation. Let's just open it up. So 073. So these are the preliminary recommendations to the SW working group from Professor Stiles, dated December 2004. And on the first page, he sets out the Stiles criteria of the power, and the turbines should be equal to the power from the ambient background noise. At that time we had a different value. We were looking in a narrow band, and I now realise is not a true calibration, but corrected that. But he also goes on to say where the attenuation factor Q comes from, and importantly, he's assuming that it's frequency independent. He sets it for the southern uplands as 50. So it's consistent with the Macbeth and Burton 1987 paper. Data from the Jaguar crash near Estonia and quarry blast data. Now, the quarry blast data reference also comes from my experience with Estonia data, and it doesn't come from surface waves per se, it comes from seeing high frequency shear waves, which Tutwell described, and from quarry blasts that are over 50 kilometers away. So it suggests Q has to be pretty high for that.
And you said there in that discussion, an explanation, that it was important to note that Q was frequency independent, the factor which he'd set. Why is that important to note?
So I think it's limiting the one of the variables. So in general, Q is frequency dependent for seismic energy which is propagating through the crust. So where there is both the energy absorption cycle, this anelastic effect, and where there's scattering through the effects, then it turns out that Q is often frequency dependent. But saying it's frequency independent, it's a good starting point, and certainly for P waves traveling through the mantle of the Earth, it's fine to assume. So the Macbeth and Burton uses frequency independent Q to a certain, well, in their 1D. So there is some frequency dependence, but it's not strong. And so we use this number as a. Actually, if I can just. So it is frequency independent, but at this time it didn't matter because we were using this very narrow band of 4 to 5 hertz. So I think as we've moved on, as our knowledge has developed, so this assumption becomes important.
And just scrolling down in this these recommendations and conclusions onto page 2, if I may, Professor Stiles notes something I've discussed with you earlier, that wind farms at the inner limit of the zone will have considerably greater impact than those situated towards the outer limit, and then illustrates that by 2 hypothetical examples. That accords with your understanding, and this note holds good having regard to the state of scientific knowledge in 2023.
In general, that's true. The furthest turbines have far less effect than the close in turbines.
You can see where Professor Stiles got his information from in setting the frequency independent at 50. Subsequent to the work which you carried out in 2004, have you become aware of any other work which has been carried out around this time, looking at Q values?
Yes, I think it became evident when reading the Evans PhD thesis that the study had been done way back in 1981.
Could we have a look at the Evans so PhD thesis, CD 14.014, 114?
it is a lengthy document.
It is a very lengthy document, and we've worked out that there's perhaps problems with pagination. But if we look at PDF pages, I think we can alight on the correct pages.
So the first one is PDF page number 182. So this is for figure 4.31, and what Evans has done is calculated the group speed, but he's calculated 1 over the group speed, which is the correct way to formally do that. That's how myself and Selby did it. And we can see on the horizontal axis that we have so sequentially at 182.
If it helps, it's just a page with a graph or a figure.
So this is CD 14014. Yeah.
I'm not sure there's an easy way to find it.
So we have 1 divided by the group speed on the vertical axis and frequency on the horizontal axis. And for the highest frequency he deals with, and these are from radio waves that have travelled from the perfect floor. So there's an explosion and it arrived at the Castleweary array. And the highest frequency he's dealing with is 1.15 Hz. 1.15. Yeah. So these numbers are actually tabulated in the appendix, but it's easier to get a feel for them. So the cross represents the group speed, 1 over the group speed, and it's around just below 0.4, so around 2.4 kilometers a second. Now, if we go on and scrolling down, you come to figure 4.4.
About 5 pages further on.
Yeah. And this is now, he refers to Q gamma on the vertical axis, but this is actually the radio wave, 1 over the radio wave Q, and divided by the radio wave Q. And at 1.15 hertz, he has Q, 1 over Q of around 0.025, so around 4. So when you look at the product of Q and V that is estimated at approximately 1.15 hertz, it's around 100, which is the same values in safeguarding styles back in 2005.
And those figures which you've taken the reporter to are then seen in tabulated form in Appendix C.
Yeah, in Appendix C. You search for UEKA, so find it. Capital U, capital E, capital A. It's something that looks a bit like this.
We had this trouble yesterday, ma'am. I have it on my copy as a PDF page starting at 322's Appendix C starts 2. Not quite sure what's gone wrong with this, but this was the appendix which has pagination at the bottom, C1, C2, and following as well. I don't think that really helps on the case. Dr. Bowers is making tabs of the hard copy. And Dr. Bowers, just so we are on the same page where they've got the same paginations now, they've been there. What table would you like us to look at first, perhaps locating it by a heading?
So for the group speed, we're looking at UEKA determined from EKAE halfway down, page ends back halfway down.
Yeah. Okay.
So it's entry number 5. You can see the frequency is 1.147. The slowness is 0.3. The bottom.
Yep.
Yeah.
Yeah.
I believe these are in my inquiry report as well. Maybe
Would it be in your recognition rather than your inquiry report?
Yeah, it's in the the inquiry. Paragraph 2.6 of my inquiry report.
Yeah.
Okay, so if you're okay with the inquiry report, you can find those numbers there.
Right. And we can see the other figure in table form, I think about 3 pages further on in the report.
Well, it's the bottom of that. Yeah, the bottom where it says QE.
Now, having taken some time to locate these figures, let's try and locate the relevance, if any, to the predictive algorithm and the Q value. Do you consider the work carried out by Evans for his PhD to be helpful?
I do, and subsequently we performed a similar analysis in our 2023 report, as we'll come to.
And why do you consider it to be helpful?
Because it's looking at a railway at 1.15 hertz propagating across the array, and so we're able to estimate the effect of the attenuation from the time when, or the place where the wavefront first arrives at the array, crosses the footprint of the array, and leave. It's coming in from the northeast direction.
The next chapter of evidence I'd like to look at with you, we're on to chapter 5, and looking at matters chronologically, if I may, is to consider proposed changes, as may or may not be being contended for by the applicant. And the starting point for this is the Herrick-Watt University report, CD 14009. Ma'am, I wonder if now going on to oops, as we're going on to another chapter, and I wonder if now might be convenient. This has been quite technical stuff.
Just have a short break. Can we come back at 11, please?
And I should say, I know this has taken some time, but I think it's important. I don't expect it'll be terribly much, well, I'll say terribly much longer, but if it assists, Madam, I'm making good progress with the witness.
Okay, back at 11, thank you.
Practical point, really, and that's my learned friend just caught me as we were leaving to say she's got about another hour and a half of evidence in chief. So, presenting case matter for her, but that will take us to about 12:30. So it takes us to lunchtime. I had checked out, and I think just practically, I think there is a risk if it's going to be that length. We've got cross-examination and then 2 other witnesses. There is a risk of us not finishing. So all I'm going to suggest is if you have checked out of the hotel, probably better check back in, because I think we might be here tomorrow.
We have the venue booked for tomorrow. We scheduled the third witness from the Ministry of Defence for tomorrow anyway, so yes. As far as I'm concerned, we can just carry on and we'll see where we get to at the end of today.
As I said, it was a practical point rather than it's booked for 4 days. So.
We can take a slightly shorter lunch. Let's just see how we feel when we finish with this particular witness at this stage. Ms. Crawford.
Thank you, ma'am. Before that short break, Dr. Bowers, I was about to embark on looking at proposed changes to Q value, and we can take this again chronologically and pick it up with the Herrick-Watt report, CD 14-009. And we know that they derive a Q value from looking at explosions at 10. Do you agree with the conclusions? I realise we'll have to look at the report in some detail, but just headline, do you agree with the conclusions that one can, with a degree of confidence, be satisfied that Q from these explosions is properly calculated at 10?
So I just hesitate to interrupt evidence in chief. But as you know, the observation was made that there wasn't a single question put to Professor Macbeth about the Herrick-Watt report. And it feels to me unsatisfactory, given that opportunity wasn't taken, to somehow ask questions which really should have been put to Professor Macbeth directly. I've got no means of using Professor Macbeth to respond. So my learned friend had her chance to question the Herrick-Watt report and didn't take it. There wasn't a single question. And what this witness has been asked to do is to comment on the accuracy or otherwise of what Professor Macbeth had to say. And I'm concerned about it.
And your concern is from where?
Fairness, because cross-examination, normal rules, if you've got a point that you are going to make, it has to be put to the opposing witness. They have to be given a fair chance to respond. There wasn't a single question on this report. What Dr. Bowers had just been asked was, well, look at the Herrick-Watt report. What do you think about it? Do you think Professor Macbeth was right? And that is out of accord with standard procedure.
Ms. Crawford, do you want to respond?
It's a matter for submission, I would have thought, in due course, but I can approach it this way rather than asking such a high-level question. Dr. Bowers, so far as the Herrick-Watt report was concerned, do you understand the methodology employed by Professor Macbeth relative to what Herrick-Watt were seeking to do?
Yes.
And can you explain to the reporter your understanding of what it was that they were seeking to do?
So they were following a very similar procedure that Dr. Selby and I followed in our inquiry, our own technical note from 2023, and that is to measure amplitudes from surface waves at various distances, and then to use regression to estimate the slope, which gives you alpha, which is the attenuation coefficient.
In your understanding of the report, how many observations did they have regard to, or data points did they have regard to?
Right, so this was the main difference, is that we focused on the second explosion just south of the array, Esdermia, because that's the largest and it was closest to the array. And there were 3 temporary deployments, temporary stations A, B, and C. So they had three observations. Now, two of those seismometers, these temporary deployments, were fairly close together. They were at 2.4 and 2.8 kilometers from the explosion. And the fourth was across the White Esk Valley at Site A, which is 4.8 kilometers away. So to do that regression, there are two unknowns and three observations. The two unknowns are the slope, which you're after, alpha, and the intercept, the 9 from 0, 0 point or 0, 0 point. So in essence, you have it's turned into 1 degree, 1 degree of freedom. So the degrees of freedom are the number of observations minus the number of unknowns that you're solving for. And they calculate the standard error on their slope, and that appears to be a smallish number. Now, the problem with this...
If you want to, sorry, Dr. Bowers, just 1 second. Could you just switch your microphone?
Well, as you can tell, I'm very unhappy about this. None of this was put to Professor Macbeth. These are criticisms of the Macbeth report for a purpose. And if the MOD had difficulties with Macbeth, when we had Professor Macbeth giving evidence, it is not right nor fair when that opportunity wasn't taken to bring those to your attention through this witness. I have no formal way of getting at that information. Professor Macbeth say that's absolutely wrong, but he's not been given the chance to do that because he wasn't aware that that was criticism that was being made. So I'm afraid my learned friend has missed her opportunity. We were very surprised, but that's the way this case has been. It is a matter for her how she presents the case, but she missed her chance, and it is not right to deal with it in this way.
Again, the general point I'd make in response is this is a matter for submission, and all I am doing at this stage is to invite Dr. Bowers, not criticise, but to comment on what he understands has been done here. It'd be a matter of, for you, ma'am, whether you accept or not what is said by Professor Stiles. I entirely accept that. I'm inviting Dr. Bowers to explain the method which was used by Professor Macbeth and this discussion of error analysis. I'm not going to invite Dr. Bowers to, well, he's already made the contrast between his technical note of 2023 and that carried out by Harriet Watt earlier. For my part, I do not understand the criticism, and I suggest it's best addressed in submission.
I think there is an opportunity here for Dr. Bowers to say more, perhaps when you're asking him questions, that he may offer views and he may offer some opinions, but therefore it may be seen as that he is being critical or commenting on this particular document. I would rather you keep to the evidence that has been covered previously and to the documents that are before us that are relevant and part of the MOD's case, rather than straying into something else. I am interested about that time this is taking, and if you go into depth into other documents that are not the key documents of the Ministry of Defence themselves, but are documents that have been submitted by, I think that we may stray into these areas that haven't been previously explored, and I can understand the concerns of Mr. Hardy on this. Can I ask your response on that?
Would you, ma'am, allow me to ask this question of Dr. Bowers and ask him to explain what's meant by standard error analysis? Because that, I think, will be of some relevance in understanding his technical note of 2023. And I was dealing with this matter chronologically, looking at the Harriet Watt report, then the 2022 technical note, and finally the 2023 technical note. And this question of standard error analysis is of some relevance because we heard something from the witnesses for the applicant yesterday about, from the scientific witnesses, science experts, about degrees of confidence which one could have from the scientific perspective.
Do you have any comments on that?
2 points. One, Professor Stiles was mentioned in, I don't know whether it was just an error from my friend. We were talking about Professor Macbeth, so it may just have been a stray reference. Secondly, of course, if it's a freestanding question, that's fine. What my concern, as you know, you've got, is reference to a document and a case which was never put to the author of that report. So as long as it's not in relation to Harriet Watt, that's fine.
Would you be able to confine it to that?
I can, Mum. For what it's worth, it's all in Dr. Barr's inquiry report. But I will just ask Dr. Barrs, if I may, the general question, and it may take a bit of unpacking, relative to what is meant by standard error analysis and what scientists are doing with that analysis.
I think it's a general point, yes, in that theoretical
I will not
way
invite
it is put.
Dr. Barrs to pick up the Harriet Watt report if that assuages anybody's anxiety.
So, in general terms then, the degrees of freedom are the number of observations minus the number of unknowns. So if I jump forward to our 2023 report, we have for the last, we deal with 10 frequencies, but for all of most of the frequencies we have 42 observations, and we have 3 unknowns, which are the 2 source terms and the slope, which gives us alpha. So in general terms we have 39 degrees of freedom, and we can calculate what's known as the standard error, which is the standard deviation from the sample. So if we're going to apply classical statistics to convert from standard error to confidence limit, then we need to adjust for the degree of freedom used to estimate the standard error. And for classical statistics, there's a statistics known as student's T, which corrects the standard error for the degrees of freedom for various confidence level intervals. These are widely available. So for our case, where we have 39 degrees of freedom, and we wish to get the 95% confidence limit, so that's where we expect 95% of the time the value of the threat will be within the bound. We multiply our standard error by student's T statistic, so the degrees of freedom 39, and get a factor of 2.02. And this is how we get our confidence bound in the figure in our 2023 report, which we can come up with. Now, if you only have 1 degree of freedom, then estimating the standard error from the sample of only 3, student's T, the value is 12.7. So you'd need to multiply the standard error by a factor of 12.7 rather than 2.02 to get the 95% confidence there. And I believe this is at the heart of the statement by Professor Macbeth that there is an apparent mismatch between our 2 statements. One, in our study, I would argue we have estimated the confidence bounds, the confidence limits from the standard error, and we get a fairly narrow band. If you calculate the confidence limits from only 1 degree of freedom, then you get bounds where essentially you can take any value from being negative up to around 4, with a central value of around 15 to 12. the errors, the uncertainty in terms of confidence bound is maximum.
Thank you, Dr. Bowers. Could I ask you to consider, first of all, your 2022 technical note, CB 14.046. And by way of introduction, could you explain to the reporter why you and your colleague, Dr. Selby, carried out this piece of work?
Sure. So at this time, my understanding of the case was that Q equals 10 in the vicinity of the array, and that could be in the consultation zone, and that could be used to adjust the propagation term in the safeguarding algorithm. So I was aware from the Jaguar crash observations we looked at in 2004 that this for the array was extremely unlikely, but realized that I probably needed a way of explaining the differences in a visual way as well as a quantitative way. So we have the explosion data to use the largest explosion in the south in June 2020, and we have the Jaguar crash data in 1986, and we undertook a forward modelling approach to model the whole of the wave field. So the idea was to obtain a 1D model which explained most of the dominant wave field propagation, and then demonstrate the differences between Q equals 50 in the top there. So the Q is, strictly speaking, the shear wave Q, but it's very close to the radio wave Q, which is usually the radio wave Q is around 7% higher, and the Q of 10 in the top layer. So that's what we undertook. I think possibly if you look at figure 5 on page 9. So if you look at the geometry there, the star is where the explosion is, the circle. Then go to figure 4. Figure 3. The circle is where the Jaguar crash is, and the circle is the wavefronts as they expand out, and you can see that the black stars are where the closest turbines in the proposed development are. So we generated in figure 3 we generated a model of the source. So this is an impact plane crash. So it's an impulse force times time hitting the ground. And then we generated synthetic seismograms on the red line and across the blue line. And then in figure 5 we take the star and generate synthetic seismograms for the explosion source at the surface, but we also, in addition to the array data, we have the three divided the data of the three concrete stations, which are marked A, B, and C. So, shall I talk through this?
Yes, please. I think it would be helpful.
Okay. So,
just trying to understand what you were doing and what your technical note demonstrates.
So the first task is to understand how to get a 1D model that's going to explain the observed group speed. So in figure 8, and following that, sorry, I got ahead of myself. The first thing to do was to estimate the origin times of the explosion and the Jaguar crash. So we knew the location of both the explosion and the Jaguar crash, and we needed to estimate the origin times. So we take the fastest waves, the P waves, and we can estimate from those times the origin time. We know the depth, it's the surface, we know the origin time, and we know the location. So we can now generate synthetic cytograms if we have a model of the structure. For that, we needed to estimate the group speed. So figure 10 shows our estimate of the group speed at 4 Hertz, which was the central frequency that what we used in the report. So figure 10 regresses the slope with the group speed against distance and plots it, and so we were able to obtain a structural model which is in table 3 on page 16. So it's in tabular form, so that there's only really parties just to look at the top first layer, the thickness of 1 kilometer, and we have a P wave, speed, S wave speed, a density, and then a QS of 50, and then we can vary that structure with a QS of 10 to make different parts. Now, this came up as a question of the effect of the depth of penetration or sensitivity of the Rayleigh wave. So one number was mentioned that it's about a third of the wavelength. My experience, and it's certainly cited in Evans' PhD thesis and Paul Burton's reports over the years, that in hard rock, we typically take that to be about a wavelength. So essentially all of the Rayleigh wave is seeing is the top kilometre or less of this structure. And we can test that, and we do in this report, by inputting this structure into another computer program which calculates the Rayleigh wave Q values at different frequencies, and that's what's shown in table 4 and table 5. So the first thing to note is that the group speed U is 2.25 at all frequencies in both table 4 and table 5, and that the Q, the Rayleigh wave QI, that's the effective Q that it's seeing with all the sensitivity to depth, the Rayleigh wave in the structure, is 53, then we have a QS of 50 on the surface layer, and it's 10.7 when we have a QS of 10 on the surface layer. So these are our model parameters, and then we generate synthetic seismogram and compare observed with predicted side by side URA with figures in the report in the 2 to 6 Hertz passband. And what we find is that the amplitudes decay with distance fit pretty well when Q equals 50, and if Q equals 10, it's far too attenuating. Another feature of note is that attenuation tends to affect higher frequencies. It's higher frequencies much faster than lower frequencies. So yeah, so high frequencies are attenuated much more rapidly than lower frequencies. With Q, so if Q is 50, you expect the relatively more high frequencies in the waveform than Q is 10. And this may be a very esoteric point, but that affects how sharp the turning point is. If you look at figure 11, you see in the observations on the left that it has a relatively sharp point when it turns, and that's mimicked in the synthetic cytogram on the right. And if you compare that with figure 12, which is where the Q is 10 in the top layer, we see that it's a much lower path. Synthetic is a much smoother turning point than in the observations. And this is not only is the amplitude not matching, but the sharpness of the turning point not matching. That, to a seismologist anyway, it's an indication that Q equals 10 not only means that the amplitude is not fitting, but it's the waveform shape as well.
So, having created this model and explained your methodology for doing that, and comparing and contrasting that model with a Q of 10 and a Q of 50, what views did you arrive at?
That the Q equals 50 matches the observations. Q rather than Q equals 10 does not match the observations. It's far too attenuated.
Now we know that Professor Tuckwell has some comments to make in relation to your 2022 technical note, and says, and this is in his supplementary recognition, which you may wish to have in front of you. The supplementary recognition of Professor Tuckwell, please.
Yes.
And if I could take you to paragraph 2.5, about 3 pages in.
Okay.
And we looked at this with him on Tuesday. He says that your technical note of 2022 adds nothing to our understanding of Q and V, and then there are various comments or bullet points. Could I pick up the first one with you? The comment is that you dismissed selected data without valid technical justification, such that their analysis is incomplete. What's your response to that comment?
So I'm assuming this is not considering the data recorded by temporary deployment Sanka area. This was discarded for 2 reasons. One, it's outside the consultation zone, 54 kilometers away from the crossover of the array. And 2, we wanted to compare the results with the data actually recorded by SDEMIA, and unfortunately the explosion at Sanka was not large enough to be recorded by the array.
So that was your reason for discarding the Sanka data?
Yeah.
The next comment is that you do not derive Q or V from the data or propose refined values.
So I think the first point is we did derive V, at least 4 hertz.
Okay.
We showed.
Mm-hmm.
And the second point was we weren't aiming to derive Q. We were addressing what I understood to be the question of relevance at the time, which was, is Q 10 or 50?
Okay. The third comment is that you did not model the ground correctly, relying instead on a 1 kilometer thick elastic layer with no topography. And I think you touched on that while you were taking the reporter through your development of the model. But could we have your comments, please, on this question of modelling?
So I think, yeah, we've dealt with the sensitivity of the array and the model development with a 1 kilometer layer. The no topography part is essentially comes to the point I made earlier, is that we're trying to get to a baseline 1D model and estimate the product QV, because that's how the safeguarding algorithm works. And the rationality behind that is to capture the dominant wave field in its attenuation, and while trading essentially using a simple model to capture that so that it's practical and implemented.
And finally, the fourth bullet, the comment is that you did not produce models which match the observed data, from which therefore no conclusions can be derived regarding the observed data. What would be your response to that comment?
So this is clearly a matter of judgment. I would add that what I understood from Professor Macbeth is that if we got close, that you could get closer if we had more complicated layering near the surface.
And what is your comment on providing more complicated layering towards the top of the surface?
Of course, it'd be nice to have the time to do this, to get a better fit or a more refined fit, but that wasn't the purpose given the constraints, the time constraints of the inquiry at the time. The purpose was to come up with a model that was good enough to demonstrate the visual semi-complicated difference between 2+50 and 2+10.
Could I ask you now to look, and you touched upon this earlier, your 2023 technical note. And by way of general introduction, why did you produce this technical note?
So, inquiry had been adjourned, and there were several criticisms, right? And there was, of course, this issue of the frequency dependence or independence of Q in the safeguarding algorithm. And my colleague Neil Selby and I realized that we now had a really good data set now with not only the Jaguar data, but the 2020 explosion and the 3 sensors and the temporary deployment. So we could have another look at these data and then see if we can interpret the value of Q in the n different frequency bands. So it was an opportunity to further investigate whether the attenuation propagation term that's used in the safeguarding algorithm was reasonable. Up to that point, it's been preliminary analysis of the Jaguar data and the kind of breadth of ranges that we've seen in the Macbeth and Burton 1987.
And what was the nature of the study or analysis that you carried out?
So, so this is TB14080.
Sorry, yes.
Yeah. So we prepared the data and then we applied a standard technique, and there's an example in figure 3, page 13.
And what is that showing us?
So this is an example from Red 4 R4 of the array from the Jaguar aircraft crash. So the top trace in the panel in blue is the cytogram. You can see there shown.
Figure 3, page 13.
So the top panel is the seismogram, converted to ground velocity, so that we're consistent with the analysis that Harriet Watt performed on the 3 temporary world stations at A, B, and C. So we have time along the horizontal axis and the velocity variation away from the baseline. And what we do is we filter this seismogram into a series of narrow frequency bands. And this is indicated in the bottom panel where we have time on the x-axis corresponding on the top panel, and we have frequency on the vertical axis, and you'll see the red crosses. And each of those is representing the frequency on the frequency axis. That's representing the central frequency of a series of 10 narrow filter bands. And the contoured area is the amplitude contour. It's essentially an envelope. And the cross marks the time at which there is a peak in that contoured surface. So at each point we can get a time and we can get an amplitude. this is done between the bounds of the green and orange lines from 1.5 hertz to 6 hertz. So we have 10 frequency bands, and we have an amplitude for all 45 stations that we're seeing. 21 observations from the Jaguar crash. We have 21 observations from the explosion plus 3 concrete deployed stations at A, B, and C. So the kind of the geometry is shown over the page in figure 4. So that's the kind of coverage, if you like, that we studied. And then I think we'll skip. So we measure the group speed, but it turned out to be very close to our previous observation, 2.25. Give me a second. I think you get 2.24 at 4 hertz, so it's a minimum change. But then the results demonstrated, I think, in figure 6. So what we're looking at here is the distance along the x-axis, and the log of the amplitude along the vertical axis, and we see the blue crosses of the observations from the Jaguar crash and the orange crosses from the explosion. And you'll see that 3 of the blue crosses have black circles around them. So that's because those data were clipped and saturated because it's an old recording system. So these were not considered. And other frequencies, similar data editing based on the quality of the contour plot that you saw in figure 3 was performed, and that's all noted in Appendix C, which is an example of yours. But the key is to then do a calculation which is based on the equation 16 that I'm pretty bit ahead of.
Okay, so you're seeking to do some, putting it crudely, plotting here. Mm-hmm. And having done that, could you explain what you next go on to do?
So the plotting of the data points, we then take those data points and use equation 16, which is on page 11. And for 4 hertz, anyway, we have 42 observations, so that's A underscore Nij. And we corrected that amplitude for the geometrical spreading, or the elastic spreading out the spherical wavefront. That's this delta to the square root of delta term. And on the right of the equation, we have 2 source terms, the Jaguar crash and explosion, and we have a term dependent on distance, which is alpha, which is then the slope. And this is how we estimate the attenuation coefficient. So in figure 6, we see that a dashed line, which is the line that comes to the slope of alpha, and we know that if you projected the distance back to 0, that the line would start at 0, 0, and this is because we've corrected for the source terms for the Jaguar crash and the explosion.
So equation 16 you've just described there is used as a correction calculation.
Yes.
Or counting calculation, which is the better way of putting it.
Yeah, so we have, in this case, 42 simultaneous equations, and we're solving those 42 simultaneous equations for 3 unknowns. 2 is the source term, and 1 is the slope. So that's why we have 49 degrees of freedom.
which you told us about earlier when we were discussing standard error analysis. Having carried out your calculations, 42 equations under reference to equation 16, what did you then do?
So the results are summarized in figure 8 on page 19. And the green dots, so for each of the 10 discrete frequencies, you see green dot. That's the best estimate of the attenuation coefficient alpha. Now the blue line is the prediction of alpha from the safeguarding algorithm, and the orange line is the prediction of alpha from the Heriot-Watt standard. We also show attached to each green solid circle are some confidence limits, which is a 95% limits, and this is based on scaling the standard error from the slope alpha by the p-value, the statistic with 9 degrees of freedom. Those green bars represent the 95% confidence limit for our measurement. So we also were aware that we're using classical statistics and that sometimes these can catch you out. So we also performed what's known as a bootstrap. There is a sanity check. So a bootstrap is where you take your population, in this case 42 iterations at each frequency, and you randomly resample your sample population with replacement and recalculate alpha. You do that 10,000 times and you get the 2.5 and 97.5 percentile, and that's your estimate of the 95% confidence limits. And what we find, and these are represented by the black horizontal bars associated with each solid circle, and we can see that the bootstrap is pretty close, at least up to 4.5 Hertz to the classical confidence band. So this gives us a sanity check. So it seems to be behaving itself, and this is, I think, to my mind anyway, a remarkable result that the QD equals 100, the alpha in the safeguarding algorithm fits between 1.5 to 4.5 Hertz in the error band. So this was a surprising result to a certain extent, a reassuring result from the safeguarding of the opaque perspective.
And you summarize your conclusions in section 5 of your note, starting at page 23, I think. And if you could just advise the reporter of what your conclusions were. We can see them in pictorial form, but it might be useful just to hear what your conclusions are.
Okay, so I think we would acknowledge that there may be, if you used a different processing parameters, you might get a slightly different result. For example, if you use displacement cytogram and velocity cytogram, you can manipulate the filter bandwidth in the passband, but this could be further work. However, we would make the following point. The results here show that the product QD is consistent with the values in the existing safeguarding algorithm between 1.5 and 4.5 Hertz. And they're inconsistent with the only other proposed values to date, but I think that's changing when I look at the report. In the Heriot-Watt report in 2022. So while there does appear to be some differences above 4.5 Hertz, the values in the Q in the safeguarding algorithm is pretty independent.
Which you told the reporter about earlier. Yeah. Now, once again, Professor Tuck on this supplementary recognition has slightly more trenchant comments in relation to your 2023 note, and we can pick this up if you still have the precognition, supplementary precognition at paragraph 2.9.
This is of
Professor Tuckwell's supplementary precognition, please.
Okay.
It says that your calculation of Q is flawed in two fundamental ways and demonstrably incorrect. The first issue at 2.9.1 is to this effect: you cannot combine amplitude data from different source events into one calculation because the sources will not create waves of exactly the same amplitude as each other. You've probably already, in your explanation or your evidence earlier discussing your report or your note of 2023, explained what you did with combinations of amplitude data. But do you agree with that criticism of your note?
So I agree with the last part, where sources are unlikely to create waves of exactly the same amplitude, but we do correct for that.
And just for the avoidance of doubt, how did you correct for that?
So that's this term in equation 16, that's A subscript rho n I, so n is the frequency and I is the source type, so the Jacob crash or the explosion.
Okay. The second criticism is this: Q should be determined from amplitude data taken from sensors arranged in a straight line along a single azimuth from the source. Failing to do so makes a number of assumptions about the homogeneity of the source and of the ground, and introduces a great deal of uncertainty. And he picks this up further on in his report. What is your response to that criticism?
So, firstly, I would argue that using multiple sources with a range of azimuths across the array and potential deployment in the explosion is trying to get at an estimate of the 1D baseline model for the, at least under the footprint of the array. And that is, I'd say, more representative of what's happening in the vicinity of the array, the propagation of surface waves from wind turbines. The wind turbines aren't in a line, and we don't know where they're going to be in the future. So it's an attempt to estimate the underlying 1D structure. Now, I understand why, historically, traditionally, a line is taken, and that is because it removes some of the uncertainty caused by the energy radiated from the source.
Professor Tuckwell then goes on to digitize some of your data, or your data, I think some, your data, in later on in his supplementary precognition to, I think, illustrate his point. Subsequent to that digitization exercise by Professor Tuckwell, did you do some further work by way of tabulating the data?
So we realised that digitizing graphs is art. So we thought it can be. So we realised that we should probably produce the actual true numbers that we used, and that was what was produced last Friday.
These are tables 1 and 2, and
yeah.
Again, I'm still not sure they've been given a number for the inquiry.
So you have them. Okay, so we tabulated the numbers, and we said these were the numbers of amplitude, collected amplitude that are used in the figures in Appendix B. I think subsequently we noted that at 1.5 Hertz that the R7 is not used, but that is indicated in the figure in Appendix C that has a black circle around it, so that's how you tell to use. afraid you probably should have tabulated it.
And the tabulated results, again, in terms which we can understand, what do they show?
So I think it's probably summarised in figure 1, where we calculated the slope alpha, the attenuation coefficient, just using the up to 1.5 hertz, the red 1 to red 7 values, and that is indicated by the red circle, solid circles. And you'll see that also calculated the classical 95% confidence limit intervals, which is indicated by the red bars, so they're much larger because they're only 4 degrees of freedom. Oh, sorry, 5 degrees of freedom, because we've got slope and the intercept. And you see, in my mind, it fits from 1.5 to 3.5 hertz. They are very similar. There's a little deviation at 4 and 4.5 hertz, and then it's back to being very similar results above 5 hertz.
And leaving aside, put it this way, so far as straight line geometry and that criticism being labelled against you, do you accept the criticism that one should confine oneself to straight line geometry?
Okay, so if I could answer this in a slightly different way. If you wanted to know what the 1D baseline structure was, you would have a grid of sensors across the whole area, and then you would be able to look at do a proper inversion to look at the attenuation variation under the 1D model. Now, we don't have that. Such experiments have been conducted over the last, in my field, I understand in the hydrocarbon field, is done all the time. And so the limitation to the straight line is one based on this concern about the source variation with azimuth. But if you use this range of azimuths, then that should just go into the uncertainty. Should just increase the uncertainty in your error bar. So the bars would just get higher. But then you use the straight line or series of straight lines.
Now, in response to your tabulation of the data, Professor Tuckwell has some further comments himself, and I wonder if you could have a look, please, at first of all his note.
Is the note or the?
I'm just checking.
Response.
Sorry, his response. Beg your pardon.
Okay.
And he agrees with your tabulation, as I understand it, but then after his own table 1, the second paragraph, he writes, the graphs associated with each frequency are plotted below rather. They show that the data for the lower frequencies 1.5 to 3.5 Hz show considerable scatter, and that therefore Q derived from these should be disregarded or treated with extreme caution. Just pausing there, do you think that the Q derived from those frequencies should be disregarded or at best treated with extreme caution?
No.
Why not?
Well, we're trying to get at a 1D model, and the 1D model says we need to estimate the slope, alpha. So if the scatter is really large, then the uncertainty, standard error on the estimate of alpha will be really large, and it will show up in the uncertainty band. And you can see in figure 1 of Friday's submission, the error bars are larger, but they're still not astronomical, and the mean value or the main value fits within it. And the scatter, I understand you're representing this with R squared. That's Tuckwell's representing this with R squared. So that's telling you the fraction of the variance that's explained by the model. It doesn't comment on the validity of the model.
And then, sorry.
So we're trying to estimate Q, or QV. We've got a 1D representation of that, and you fit the data to it. And there's uncertainty. You have to estimate the uncertainty, and we've done that in our figure 1 here using classical statistics.
And the second comment from Professor Tuckwell is that data from 4 Hz upwards presents a better linear fit, where a value of 1 over Q would indicate that all data points lie perfectly on a straight line. What is your response to that comment?
So, I mean, that's true from the data, but it's for this limited data set, but it's not true when we use 40 data. We'll always find, by chance, a benefit. That's why we calculate the error bar, and certainly it's complicated.
And what about looking at 4 Hz and upwards?
In our analysis, or in?
Well, if it's suggested that one should just look from 4 Hz upwards, I'm not sure if that is being suggested.
So, well, there are 2 points I think I would make. One is that the majority of the seismic ground vibration generated by wind turbines in the proposed foreside development lies at frequencies less than 4 Hz, and that's in figure 1 of my inquiry report. We'll come to it later. And the other point I think is a wavelength issue. So as you go up in frequency, so the wavelength becomes shorter, and so it's the area it's sensitive to structure off of the direct path becomes smaller than at longer range. So it's seeing shallower and less natural structure. So I don't think I can prove it, but my intuition suggests that I think this is what you would expect when you look at the data.
You mentioned your inquiry report. In the earlier part of your answer there, could I ask you to look at section 4 of your inquiry report, where you address the issue of passband and present figure 1? Is that what you were alluding to in that answer?
Indeed.
And can you explain what that shows?
So this is on the left panel is the prediction of the power spectral density at the array, the vertical axis, with various frequencies on the horizontal axis. This is for what I take to be a typical turbine proposed in the foreside development. So this has both the source term, propagation term, and the receiver stochastic effects in there, and you can see that the majority of the power is below 4 Hz. So this is demonstrated by the panel on the right, which is essentially the area under the curve as you move left to right with increasing frequency.
Going back, if you still have it, to Professor Tuckwell's note, the next paragraph on page 1. At 1.5 Hz, you can match the value presented by yourself if you exclude the data for sensor R7. And then notes it does this, the value for Q drop, and it matches your value. Could you tell the reporter a bit about the relevance of R7, sensor R7?
Sure. So if you go to the CD 14080 and page 48, in Appendix C, figure C18. Okay, so I guess if we go to C17 first, which is what we would probably call good data. So you can see a very clear contour plot that crosses clearly falling along the ridge of the contour plot. But then if we look at C18, as we go down to lower frequencies, it starts to become a little messy until at 1.5 Hz, along the orange line, you start to see different peaks. And because that didn't seem to be, it seems to be some other phases interfering with the surface wave, or either it's 3D effects or whatever, but we felt that those data were not reliable. And I guess it's a little bit subtle, but there is a black circle around that data point indicating that it's not real.
And why didn't you use it?
Because it clearly doesn't fit with the other data points. I mean, in the end, this is a judgment call. I accept that. But at some point, use some data editing to remove the clear outline.
Okay. So in your judgment, it's a clear outlier. And just to go back to Professor Tuckwell's note again, he then goes on to state, if data from this sensor is to be excluded, then it should presumably be excluded for all frequencies, which reduces the value to be across the board. Do you agree with that?
No, it's clear from that figure C18, the other data. The data at other frequencies is fine in my judgment.
Okay. Just bear with me one moment. Next chapter, if I may, I think probably onto chapter 6, and that is utilization factor. We've heard something about utilization factor. What is your understanding of what's meant by the utilization factor?
So I think it's probably helpful to look at section 6 of the design engineering 2014 report, so that's CD 14-004.
Mm-hmm.
So their figure 59, which I think this was referred to before, is the plot from Professor Stiles' 2005 report. So what he did here is he had 3 months of...
Just so that's page 71.
Yeah. So he had 3 months of production data from 4 wind turbines. That one was done with. Another, I think, is just west of Sanker. Another is in northwest Scotland. So from a large area across Scotland. And for each time period, or I don't know the time period that you used, we calculated the actual electrical power generated versus the combined total rate of power. And then you look at that over time and look at the cumulative curve, which is aggregates them, and concludes that 20% of the time the wind farm production of these 4 wind farms is 60% or greater of the sum of the rated power. And this was what was used to calculate this utilization factor, which was applied to the mean square amplitude, which in the Stiles model had that mean square amplitude being proportional to the electrical power. So this was looked at again by a contractor prevailing wind farm analysis limited, and this full report is in Appendix E of design. 2014 report, titled Utilization Investigation. And they followed a similar process to Professor Stiles. They received wind speed data from wind masts and anerometry from 34 wind masts from developers, but it needs to be rain confident. From these, they chose 14 masts geographically to represent the consultation zone, so out to 50 kilometres from the and they found 2 years where they had concurrent data for these 14 masts. So this is described in the training report. So those 2 years, there were some gaps, and they used standard method to fill those in using wind speed models. We now have 2 years of current data at 14 sites. They extrapolate the height to 80 meters, which is the height reference for the wind turbine source term in the safeguarding algorithm. And then they assume there's a wind turbine, standard wind turbine at Siemens 0.3, the power curve, various wind speeds at each of these 14 sites. And in each 10-minute period, they calculate the predicted electricity produced at each of those sites and compare it with the ratio of that with the total rate of power. It's like Professor Stiles did, but this is for 14 sites using anerometry and in the consultation zone. So their results are summarized in figure 60, page 72. And the cumulative curve, when you look at the 20% decline, which is the marker chosen by Professor Stiles, 82% or greater of the electricity produced, total rated power of electricity produced is predicted to have been produced. So this suggests then that was defined for the utilization factors. This ratio is 0.82. However, the current safeguarding algorithm using the energy scaling means that it's the power that is proportional to the electricity produced, not the amplitude. And so we can take the square root of that, so it becomes 0.9. It's saying for this study, 20% of the time, the utilization factor using that criteria should be 0.9 times the square with predicted cumulative of the ground vibration. Now, at the end of the story, they realized, as I mentioned earlier, I realized that this isn't quite what you want, because the turbines that are closer to the array will have more impact than those that are further away. And so what you need to know is how the wind varies across the consultation zone, and especially around the vicinity of the array. So you need to know the length scale of how the wind varies. So if I'm 15 kilometers to the east of the array, is the wind the same strength as 15 kilometers to the west? I'm not an expert, but I suspect it probably is, in which case the utilization factor will be 1. But if you're 40 kilometers away to the west and 30 kilometers away to the east, they're probably likely to be different, in which case you would correct for that utilization factor. But that has not been calculated. As I point out that the prevailing data set could be repurposed to do that, but that work has not been undertaken to my
knowledge. Putting matters simply, does the utilization factor represent the percentage of time at which wind farms, wind turbines, are operating at a particular capacity level. So if we have your utilisation factor set at 1, does that equate to all turbines within the relevant zone operating at 100% of the time?
No. Well, depends how you interpret it, but as it's been explained in the SI report, it means that 20% of the time, hypothetically, we reach the threshold in the prediction, then 20% of the time that threshold will be met. Plus, in realistic terms, because it's a random process, it will on average be met, but it will be sometimes lower, sometimes higher, because it's a random process. But on average, it will be at 20% of the time.
Just a few further matters, Dr. Bowers. In your inquiry report at 11.1, you conclude that the prospects of the proposed foresight development not having a significant and detrimental impact on the detection capability of the array are extremely unlikely, given the size and proximity of the development to the array. Do you stand by that statement?
Yes, I do. It's the dictate curve, and this is also based on the experience of the Grafenberg array, Stanley,
which you refer to in your...
It's in my report. And given R10 is 3.9 kilometers from the closest turbine, they will
trash it, did you say?
I did.
That's presumably a non-scientific technical term.
It is. It's been a long.
And again, in non-scientific language, you use the phraseology "too big, too close." Does that encapsulate the underlying reason for your statement to 11.1? But it's supported by the research work which you've described in the course of your evidence this morning.
Yes, that informs that quickly summary.
That's all the questions I have for you, but if there's anything else you would like to inform the reporter about, please let us know.
No, that's...
Thank you. Those are all the questions I have.
Continue, Dr. Bowers, or would you like a break at this stage? Okay. I think then perhaps we should have a shorter lunch, if that's acceptable. We can get back, and then we've still got quite a lot to get through, and potentially it looks like we might go into tomorrow with the final witness.
Yes, subject to one point, it's a very practical point, which is important, sandwiches, because I don't know whether they're available. Our lunch is being prepared by the hotel, so could you check? I mean, I would like if we're going to have a lunch break, I would like some lunch. I don't just want a break, so what's that? If not, we can go to Sainsbury's, so maybe...
What time have you booked for lunch?
The sandwiches just appear on the side table, so I don't know.
How about we come back at 1 o'clock?
I think that
should give everybody enough time.
Yes, we can go to the shop if not. Thank you.
Okay, thank you. Welcome back, everyone. Just been handed a copy of, as we discussed this morning, amendments to the draft condition that the applicants put forward. So we've got a copy of that in front of us. It's also been provided to the Ministry of Defence. So That will be available for the witnesses later on. Okay, Mr. Hardy, do you have questions in cross-examination of Dr. Bowers?
Perhaps not surprised to hear me say yes, I do. And let's start with a list of documents. So there was the list prepared that I submitted on Tuesday. I don't know whether you've got a copy of that, Dr. Bowers, but they were the documents that we were going to in chief. If not, I've got a copy for you. And in addition to that, there are a number of others. So CDs, and they're in a run. I've got them neatly collected in one folder, but sequentially 74. So 14074. That's the statement of agreed matters. 75. 77, 78, 79, 80, 88, 89, and then there's APP 70, which is the Elliott report. And in addition to that, it would be helpful, I'm assuming, that you got access to the various reports and recognitions and statements. I don't know whether you have those, but it will be useful if you do. So that's the original inquiry reports, well, the inquiry statements, the reports, and the recognitions. So just in general terms, really. If you need time, anytime you need to see a document, then you just stop and we'll go to that. I just want to start with some general points, and I'll say this is a planning inquiry. It's not a science convention. I'm going to cut through this as quickly as I can. And I was interested to hear what was a long delivery of evidence, very sort of controlled. At the end of your evidence, you showed some emotion, and that was you thought that the turbine, the wind farm array, was going to trash the array, and you said too big, too close. You would call that evidence, and it struck me because it was quite colourful language. I just want to understand, is that your predetermined position? Your thoughts about this proposal, regardless of what may come in the science, is actually you think it's going to be too big, too close, and it's going to trash the array.
So, Mum, I think on the basis
of course.
Okay, so yeah, so I think it's on the basis of the evidence I have read and the research that we have undertaken since February last year. But the conclusion is it's too big, too close.
Yes, but there's something called determination bias, isn't there? And you're a scientist, absolutely, writ through your character. And one shouldn't prejudge science, should one? Should have an open mind.
So again, I entered this with an open mind in February last year and have read around the subject. Of note is this paper by Stamler and Serrano on the Grafenberg array. It's published in 2016, and that's so striking, the effect that happens when you put turbines within 5 kilometers of a seismic sensor. Mm-hmm. So then we attempted to quantify that in terms of the area around the array, and that's the research in the 2 technical notes. CD 14046 and CD 14080, and it's on that basis.
Yes, you see, that's not really the point, is it? Because we're not here to ask for consent to build the array tomorrow. You know that. What we're here is to ask for consent subject to a suspensive condition. So nothing gets built unless that suspensive condition is discharged. And forgive me, but you seem to be going into this with a very closed mind of, well, too big, too close, going to trash my array. That's not scientific, is it?
So I can only repeat my answer that I came into this having worked on the safeguarding GDSW working group in 2005, again in 2012 through to 2014, and the new evidence, as I saw it, was that the propagation term was not correct. We have analysed that with new data, and I reached the conclusion that the propagation term controlled by QV, which equals 100 in the safeguarding algorithm, is relevant, in which case, given all the other parts of the safeguarding algorithm which we've studied since 2005, I come to the conclusion that it's too big and too far.
Give me again, it's not the question I'm asking, Dr. Bowers, it's this. Going forward, science that can be collected, you would look at that with an open mind, wouldn't you?
Of course. So one can never say never, but I think it's highly unlikely that the new evidence, if it's gathered, would be significantly different to change frankly, my conviction that it's too big and too close in this case. I'm afraid.
And you've got world-leading scientists on this side of the room who disagree with you on that. So if you have an open mind, then the data can be collected. If you're right, of course, you get a badge. Well done, Dr. Bowers. And if you're wrong, well, then actually one of the objectives of the Scottish Government to maximise renewable energy may be able to be completed without degrading the array. Those are the options, aren't they?
So I repeat the statement within my expert opinion, and it's based on nearly 2 decades of studying data and thinking about this problem. I come to the conclusion that it's too big, too close. If you gather further data, of course, more data is always helpful, but it seems to me that the hurdle for a wind turbine farm that's just 3.9, the closest turbine is 3.9 kilometers from the red pen sensor. It's too big an ask that our current scientific understanding is so wrong that it could possibly happen.
Back to my point, we'll move on. I think the point's very obvious to people in the room. You've got, as I say, world-leading scientists on this room who disagree with you. So what you do is you undertake more data, get more data. That's further science. And that'll go one of 2 ways, won't it? If you're right, you get your badge, and the farm doesn't get built. However, if you're wrong, then you can build more renewable energy, which is what the government wants to do as one of its 2 objectives. That's the position, isn't it, at this inquiry? You may be right, you may be wrong.
So my understanding is to give my expert opinion. Given that, clearly further data, always useful. It just seems to me that the parameters are within the uncertainty that we have calculated carefully and presented, that it's highly unlikely that the result would be different.
Let's just test that a little bit. Highly unlikely, of course, nothing is 100% certain, certainly not before you've got the data. You can't be predetermined, so you are accepting, as I think you must, that there is a prospect that the data will show that the wind farm could go forward without unacceptable degradation. That must be right.
It's highly unlikely. I can't quantify it apart from to say that it's well outside the 95% confidence limit bound that we've calculated for you. I haven't done the group calculation combining the uncertainty from all of the elements of the safeguarding algorithm. That is an exercise that could be undertaken, but my intuitive feeling, having studied this problem for nearly 20 years, is that it's highly unlikely.
Probably move on with this last question. That likelihood, you can't exclude the possibility that you're going to, your evidence is not going to carry the day entirely. That prospect is the prospect which ought to be tested by further science. As I say, there's no risk, because if you're right, absolutely, Dr. Bow's naming lights, foresight doesn't go ahead. But if you're wrong, or if in fact the data isn't as you suggests, then on an empirical basis, foresight may go ahead. That's for the planning system, isn't it?
It is for the planning system, and I'm afraid I can't comment on it.
But we'll go, can't comment on risk. All right, well, I'll pick that up, but that's helpful and short circuits a lot of cross-examination. Thank you. Let's start with matters really of agreement, and I'd like to go to the original statement of case from the MOD from May 2022. So that's the original statement of case.
Yes.
Just want to ask what part you had to play in formulation of the statement of case.
Very good question.
Not the most technical question to be asked this afternoon, but just would like to know. Badged as a Morton Fraser document, but did you read it before it was submitted?
Yes, it was consulted. Yeah.
Do you agree with what was in the statement of case? Presumably you do. You'd have picked up it if you didn't.
Yes, so certainly I contributed to paragraph 610.
Look at what the statement of case has to say. Not all of it, because we don't need to go there, but paragraph 8.14 to start with. So at a further meeting of the EWG, December 2020, we'll come back to this, but Xi Engineering presented the results of phase 3 of their technical analysis, which concluded that the current SDME or SGV predictive model used by MOD is no longer suitable. That significant additional capacity within the SDL threshold was capable of release, and using measurements from a further 7 sample sites already built within consultation zone should reduce any risk of replacing the current SDL or SGV predictive model, but noting that any capacity found to exist within the SDL threshold would rapidly be consumed if no increase to the exclusion zone was made. It's a long sentence, but just want to pick on that first clause. The current SDL or SGV predictive model used by MOD is no longer suitable. Agree with that? So in your statement of case, of course, it's an important document because it sets or articulates the case that is being made.
So the context of this was in analysing the source term specifically. What the problem we were faced with in 2014 was that a predictive model was required that didn't tie developers to any specific wind turbine type. And what we'd found is that turbine at Clyde had this strong resonance that we could see that it hadn't seen in the 2 other turbines that we had measured at Craig and Dunlop. So we came up with this worst case turbine model, which had both of those features. The further measurement by Xi showed that, in general, apart from maybe one of the turbines that was being measured, the worst case turbine source term was conservative by design. So the proposal was to go forward and measure these 7 other sites, and it was found that for specific sites and specific turbine types that indeed the worst case turbine model was conservative by only 30% in power.
Thank you very much. A short answer required, really. I'll let you answer. I'm not going to cut you off, but 814, that's the MOD's case, isn't it? Certainly as articulated, put out in the public domain, that the current SDLM or SGV predictive model used by the MOD is no longer suitable. Do you agree with that or not? Yes or no?
Well, that's certainly the view of the MOD and the SDLM working group.
Is that your view?
I could see the argument for making that, and I've reviewed, or I'm in the process of reviewing these Xi reports.
So you take a different view to the statement of case, do you?
Not necessarily.
I don't understand.
I
don't understand. Now let me let's try and unpack that a little bit. You see, there's a planning inquiry, and what the parties are asked to do, for good reason, is to set out their formal case. That's the purpose of this document. And we have to look at that and see what it says. And there's a clear statement there that the current SDLM or SGV predictive model used by the MOD is no longer suitable. And what you've said is MOD, EWG's view is that. But you say something different. Where would I see that you take a different view to that?
So I'm in the process of reviewing those documents to see if I agree. I explained why I understood there was this view that I was underestimating, and it certainly seems reasonable, but I haven't formed a firm opinion because I'm still in the process of reviewing those documents and thinking about it.
So there's a difference between you and the MOD. We'll come on to what else is said in this statement of case in a moment. It's very interesting. Where would we see on this side of the room that you disagree with what's been stated in the statement of case, and indeed what you've just said is the view of the MOD, EWG? Where do I see that?
So I haven't said I disagree. I just say I want to think about it. I'm not sure.
Well, the time's now. I mean, we're here. We've been preparing for this for the last 18 months, and this statement of case is the base document for the MOD's case. And it's very revealing, if you don't mind me saying, that the principal witness isn't sure whether he agrees with the MOD's case. And the first time that comes out is in evidence this afternoon. You see the importance of it?
I haven't said I disagree with it. I've said that this states that the SDLM working group concluded.
Right. Let's have a look at some other statements, see where we get with those. So 8:15 then, the EWG meets again. There's a further discussion on the need for the phase 4 technical analysis taking place. At that stage, the Scottish Government expressed the view the undertaking of it was essential to provide the evidence upon which any future policy decisions would be based. Just as an aside, do you think the phase 4 work is required?
I think it's been completed now.
So you agree that was essential?
It's certainly helpful because it's more data. Sure.
So more data helpful, but phase 4 you thought was, the word here is need, so that there's a requirement. So you agree that there was a requirement and you're happy that that's been done?
I don't control the SDLM working group. I'm just a technical advisor, and clearly more data is helpful in trying to understand the problem and provide advice.
Well, we'll come back to that. It's a very helpful answer, Dr. Barr. And then 816, at present, as a result of the Phase 4 Xi engineering technical analysis work undertaken for the EWG, MOD agrees that the current SDL-MUIR SGV predictive model overestimates the contribution of existing wind farms towards the exhaustion of the SDL-MUIR threshold, and that it's appropriate for a new SDL-MUIR SGV predictive model to be developed for calculating the SDL-MUIR threshold contributions from future wind farm proposals. Do you agree with that? That's the MOD's case.
Yes, I agree. But you could update the current predictive model.
Well, in 814, no longer suitable, you had some problems with that. 816, isn't that the same point? Well, why suddenly did you give a different answer? If it's not no longer suitable, it's because it's not appropriate. No?
So, there is a subtlety here. So one is the research that the SDL-MUIR working group is undertaking with Xi to understand if there is capacity in the future. And the question about the current safeguarding model being suitable in the absence of something to replace it, I believe a different question.
In terms of overestimating, so back to 816, the SGV predictive model overestimating contribution, do you agree with that?
I think I've explained before, Ma'am, that yes, for certain turbine types, certainly the 10 that have so far been measured, the worst case turbine used in the safeguarding algorithm does overestimate, and it was by design.
We get further into that paragraph, and we can see a sentence: once that research is concluded and accepted by the MOD, the EWG and MOD will require to develop a new algorithmic predictive model, which will take into account a variety of different input information. So that's a sort of mandatory thing, isn't it? If you do that, actually, there's a requirement, not a nice to have, but there's a requirement to do something different.
So the requirement is to develop a new algorithm and a predictive model that underpins that.
Okay. We then turn on in the document to paragraph 11.4. Having regard to what's said and accepted by the MOD at 812 to 816 we've looked at, it's clear that the current SDL-MUIR SGV predictive model used to calculate SDL-MUIR threshold impacts requires to be reassessed. We've got that language again, haven't we? Requirement.
I agree. It should be reassessed.
Okay. So, having asked that sequence of questions, can you just clarify for me where you think your personal professional view, of course you're under an obligation to give your professional view, where your views differs from that of the MOD, if it does?
Well, I'm not sure it does. However, there may be positions that MOD take that I'm not qualified to take a view on.
Well, you see, in an answer about 3 or 4 minutes ago, you told me that you thought your position did differ from the MOD. I just want clarity, really, on where we are. So do you take a different view to the position stated by the MOD?
So are you referring to 8.1?
Any of it. I just want to know.
So under 8.14, the current safeguarding algorithm for the predictive model not being suitable, that is the view of the SDL-MUIR working group. Considering the phase 3, 4, 5 reports. When I get a moment after this inquiry. Is there anywhere else? Sorry. that should be clean. So, okay, so
Before, yeah, Dr. Bowers is softly spoken, so maybe.
Just asked you keep your voice up then, I think.
right. So under 814, it was the SDLMIO working group that concluded that the predictive model used by MOD is no longer suitable. So I have to consider what's going to replace that before I can conclude whether, from a scientific point of view, it's suitable or not. That's a process which is, I guess, ongoing.
All right. Anything else, or is that the limit of it?
So under 816, I agree with the MOD that the current model over-predicts for existing wind farms where it's been measured.
Thank you.
And that it's appropriate for a new predictive model to be investigated.
Before we leave this document, can we just pick up on something else, and that's in 11.22. So 11.22. What's said is, whilst recognising that it's quite proper for the current SDLMIO SGV predictive model to be re-examined, the MOD's position remains it's the only model that's been scientifically established capable of calculating the SGV from wind farms at the array and thus ensuring the safeguarding of the array. So it's what we've got, and until something else comes along, it's what we use. 2005 Styles report, so skip a sentence. The 2005 Styles report, as updated in 2014, is the only substantive research contemplated in this matter, or completed in this matter, remains the best available science in this area. Now, this was written in 2022, but you agree with that, don't you?
I agree with that, yes, ma'am.
In terms of, it's not a sort of trading card game, but in terms of eminence of scientist, let's start with Professor Styles. He's a world authority, isn't he, in this field? And in fact, the MOD was content to rely on the Styles report for a very considerable number of years.
It's certainly true that the work with Professor Styles in 2004, 2005 was kind of the first generation of the safeguarding algorithm.
Yeah, and he's the same Professor Styles that was, unfortunately can't give evidence, but has written reports, and there's nothing to suggest, is there, that eminence should be taken in any diluted way. He's still the same guy. MOD trusted him for a very long period of time as being the sole source.
So I respect Professor Styles' reputation and his work. However, there are cases where there is naturally a disagreement when it comes to professional judgment. And I would add on that I believe that is due to our different experiences. Mr. Styles has a shallow earth geophysics background, and I have a background in forensic seismology and monitoring comprehensive nuclear test ban treaty and underground nuclear explosions. And it was that combination of the expertise in shallow earth geophysics and field deployment, and my knowledge of propagation modeling and source modeling that led to the 2005 safeguarding algorithm.
So, I mean, one way of looking at that difference in view, of course, is to follow an agreed protocol to consider further data, isn't it? To look at where that lands. So you've got respect for Professor Styles. He's saying you should do something, well, why not do it with an agreed protocol to see where that data lands?
No objection to gathering more data, and indeed I propose further work.
We're going to come to that,
in my recognition.
Have you finished? Have you finished your answer?
Well, this is in the context of the safeguarding algorithm in general and the work of the SDOMIA working group to update that algorithm as appropriate.
I can pick up. So, Professor Macbeth at the same time, it's not actually mentioned in 1122, but similar questions. He's a world leader in this field, isn't he?
I'm afraid the only papers I've read of Professor Macbeth are from his PhD thesis in the early mid-80s. I'm afraid I haven't followed his career since.
Then eminence can be left to submissions. And similarly, there's a high degree of respect that you've got for Professor Tuckwell, who sits next to me.
Again, different fields. There's no reason not to respect Professor Tuckwell, but I'm really unaware of his work in the field of forensic seismology. I'm aware he's done some work for shallow earth geophysics in the context of the on-site inspection work under the CTBTO, but I have not followed that closely.
All right. Let's leave that document there and move on to the updated statement of case then from November 22. So, similar question. Did you play any part in the writing of this document?
So I certainly reviewed it, and I probably contributed to 3.7, 3.8, 3.9.
Taking that you saw it, and it's a corporate effort, isn't it? You're happy to sign up to it?
It's not my statement of the case.
No. But it is the there's a single document that comes out in these sorts of inquiries, and I mean, you've read it. Do you want to say you disagree with it?
No, I don't disagree with it.
Then look at 3:13, if we may, which is to do with the updated proposed scope of works, which we're going to come to. But the updated scope of works, October 2022, essentially the same problems as the original. The MOD's position, as has been explained to the applicant, is that there needs to be a clear outline of the underlying science with a description of reference to the analysis methods proposed, the experimental setup and expected outcome, and a defined basis for assessing that outcome. In general, the updated scope does not define deliverables and what the criteria are to measure success or failure against those. Relies on a range of poorly defined research projects, the outcome of which is extremely unlikely to result in MOD removing its objection to foresight development. Furthermore, the anticipated timescales for the proposed works and reporting on their outcome are not indicated. So there's quite a lot in there. We're leaving policy and law, risk allocation, that's for another witness, that's not for you. So we can leave we've dealt with the extremely unlikely point. I've got what I need from you on that. But let's have a look at the points that are being made. So a clear outline of underlying science, knowledge of the experimental setup and so on. If that were to be provided, so say a decision maker was to take a different view to you, then presumably the MOD and you would be satisfied. You think it's going to make no difference, but this is about the extent of the effort, isn't it, and the scope of the work.
So I believe I did say something about this in my evidence.
Well, now's your,
Updated
absolutely. Now's your chance to give your evidence to the reporter as your resting position.
It's in my inquiry report. So under, I guess it starts at 8.2, where we review the joint meetings with experts. So at the first one, we were discussing mainly the further work outlined in my recognition.
Come to, yep.
And then subsequently, 8 months later, I've done some extra work, which was in this AW 2022 note. And that
Let me just cut, I don't want to cut you off, but maybe you're not answering the questions I'm asking. So 313, the criticism, MOD's position, is that there needs to be a clear outline of the underlying science with a description of reference to the analysis methods proposed, comma, experimental setup, expected outcome, defined basis for assessing that outcome. So they're the problem. So the simple point I'm putting to you is if the reporter didn't share that view, that actually there was a clear outline of the underlying science, there's a clear understanding of the experimental setup, the expected outcomes, and defined basis for assessing that outcome, then presumably people would be happy.
I guess I can only speak for myself. So for me, those points that are made are not addressed by the draft scope of works. And I try to explain them in my inquiry report as to why. And I think I elaborate then.
We'll come on to that, the detail. I'm not going to cut you off. We are going to get to it. But your view is that you're not satisfied that the scope of works complies with those criticisms or addresses those criticisms.
I'm not saying all of them, just at least a few, and I can't remember which
we'll
ones
come
I
on to
pulled
that.
out.
We'll come on to the detail of it. So I want to pick through it, but that's the general point. And whilst the condition is not for you, it's a planning matter, over the page on paragraph 5.1, just to tee this up for later on with other witnesses, it's said that the applicant's proposed condition is incompetent because it relies on a range of poorly defined research projects, themselves subject to amendment on an unspecified basis, without defined deliverables and criteria to measure success or failure against those. Now, just forget conditions and planning law for a second, but that poorly defined research projects without defined deliverables and so on, that's pretty much the same thing, isn't it, as paragraph 313. So presumably you think it's poorly defined research projects without defined deliverables and so on.
Certainly, that is my view, and I think the problem in me trying to answer this further is to explain, I probably need to explain that I do not know how to evaluate a scope of works. These judgments came from a comparison of the proposal I wrote for Estomia Working Group in 2012, and it was really on the basis of that experience that's what I was expecting from the draft scope of work.
To take a note of what you said, you just said you do not know how to evaluate a scope of works, and that your reference point was what you put to the EWG. Yes, is that it? Okay. So in that, and that's a very straight answer, you're a scientist, this is a planning inquiry, it may be, at least open to this suggestion, that you're not the best placed to determine then whether or not the scope of works meets the planning tests?
Oh, definitely not.
Definitely not. Thank you.
But I can comment on the science.
Yeah.
And the experimental design and the expected outcome.
Yeah. In terms of dealing with planning conditions and scopes of works, do I take it from that you've not done that before?
Correct.
So this would be the first time that you've looked at or been tasked with assessing a scope of work subject to a planning condition.
Is this actually the scope of works, or is it a draft?
Draft scope of work doesn't matter. Either draft scope of work, so we'll come on to that. But
okay, yes.
This is the first time. Good. Now, see, why that's important, Dr. Bowers, and it may be that this is the heart of the difficulty, that you're looking as a scientist for something in a scope of works that doesn't need to be there for the planning system. And actually, if you've not looked at that question before, you wouldn't know, would you?
I agree.
Yeah. Okay. So it could be resolution to this is your absolute scientific mind in your day job has put you in a position of saying that the applicant needs to do more or with more specificity than actually the planning system requires. Are you at least open to that?
I do not know what the planning system requires.
You do not know. Well, that's very helpful. Thank you. So let's move on to the next document, and that's your I want to go to your precognition, your first precognition, if we may. So I'm particularly interested in section 13, which is on internal page 21. But before we get there, I want to ask a general question. And in the course of your quite lengthy evidence in chief, what was apparent to me was that you changed your mind on a number of things as years have gone on. No criticism, but as data has come forward or a particular piece of research has done, you've taken that on board and you've made some changes, haven't you?
Indeed, we're constantly learning.
You're a scientist, absolutely, and you learn through data, different studies, new research. That's what happens, isn't it?
And reading. And
reading, of course, yeah.
And talking to other experts.
Yes, and with an open mind. You're not prejudging that. What you're doing is looking to see what comes along, and you may change your position or you may not.
That's certainly an idealised view, and one that I would like to adopt, but I suspect I'm not that pure. But that's certainly my intention.
Well, is that because you've got a predetermined outcome that you don't want this wind farm to go ahead? Is that what the MOD tells you?
No, I think what I meant from that, ma'am, is that I'm looking at this from the point of view of a forensic seismologist and the impacts on the array. And other scientists come at this problem with different backgrounds, and engineers, indeed. If I could add that working with Professor Stiles in 2004-05, added this shallow geophysics to my seismological expertise, and working in 2013, 14 and 15 with design engineering led to a greater appreciation of the engineering constraints of wind turbines. Mm-hmm. And so I'm aware that my own experience isn't the whole answer. I could put it that way.
Those people who might provide or fill in the gaps may be those with slightly different fields. Say, Professor Peter Stiles and Professor Macbeth, Professor Tuckwell have all got their important part to play, haven't they?
Potentially, of course.
Yeah.
Everyone brings their own treats to your
potential
target.
is all I need for my notes. Thank you, Dr. Bowes. So 13, as scientific understanding of the effects of wind turbines increases, there's always the possibility of further work being undertaken to improve that understanding, which may have proven to be reliable and acceptable, result in changes to the approach. That's the open mind point, isn't it? And if you have got an open mind, you might make changes.
Absolutely.
Yeah. 13.2, prepare for the inquiry, number of areas for potential future consideration. So we've got 3 subpoints to this. So research into spatial variation of Q and V in the consultation zone, challenging project, especially if field trials are required. 3-dimensional modelling is now feasible at the frequencies of interest. Literature review. It may turn out if the Rayleigh wave efficiently converts to shear light waves, in which case Q may be significantly larger than 50, may not. But the point is that you can, or one of the areas of potential work is research into the spatial variation of Q and V.
Indeed.
And over the page, significant research into predicted versus observed SGV from operational turbines. And then examine how to interpret the threshold in terms of the wind speed and direction in the vicinity of the array. So there what he's saying is, look, yeah, it's not a finished article, do further work, might change my mind, depending on what's thrown up there.
I agree.
Okay. And what that led to was an email from, or a table, which was attached to an email. And you'll find this at CD 14088. You'll be familiar with it, I'm sure. .088. You have that?
Mm-hmm.
And that was attached to the email from Mr. Keith Campbell, was a table of work or opportunities for discussion which took place in the experts' meeting regarding what could be agreed in the statement of agreed matters. That's the purpose of the table, wasn't it?
Yes.
Yeah. And the paragraph numbers, we don't need to go to all of them, but they refer back, the document that they refer to is the precognition, the one we've just been in.
Correct.
Yeah. So things that were thought by Professor Tuckwell to come from your precognition that might be worthy of further discussion and agreements are in that list. They include, I know this has been important to you, 12.13, addressing the effect of Q and V on the source term, for instance. And wind speed, 13.21, research into the spatial variation of Q and V in the consultation zone, which you've just looked at. So there was some chinks, if you like, that Professor Tuckwell saw in your work to say, well, actually, there's potential here to discuss this further and take matters into the statement of agreed matters. That was what that table was trying to do, wasn't it?
Yes.
And that resulted in the expert meeting. And we've got a note of what was discussed. We can see this at CD 14.075. You want to turn that up? You have that?
I have that.
Yeah. So discussion, summary of the points discussed, and you'll see there's a cross-reference to the paragraphs in the table, unsurprisingly. And we don't need to go through all of it, but we can see, for instance, the bottom bullet point, just to pick on one that you, again, the one that you're being exercised about, paragraph 12.13 highlights the fact that WCT source term needs to be considered if Q and V are changed, and the physical basis for the energy conservation used in the algorithm would need to be considered. So the discussions in the expert meetings match that table which came out from Professor Tuckwell. The subject matter of the meeting.
Yeah, that set the agenda.
Thank you. I want then to turn to your technical note, which we can find at CD 14080. So move on by 7 months from that meeting. And you do some work, and you produce your technical note we can see here. Now, there's criticism made of it, which we come back to. You've seen what Professor Tuckwell had to say about this, but that's not my concern just at the moment. You can see the summary on the front page, the abstract, so final paragraph. Finally, we suggest further research that could be carried out to quantify the uncertainties and variation in Q and V values in the vicinity of the array. And that's a summary of your section 6, which we can find on internal page 24. And if we turn to that, possible future work, we can see we consider it extremely unlikely that future work will lead to robust evidence of a need to change the baseline values. The same. You get your caveat in the vicinity of the EKA array, but further search can always help to refine our understanding. We suggest the following possible additional work, although of course that's not exhaustive. So additional experiments and temporary deployments, additional data always useful, provided any future deployments collect waveform data in accordance with a clear aim of what an experiment is hoping to achieve. Measurements for any future deployments must then be combined with existing results in an appropriate manner. So data is good. You want data, and what you want to do is be able to compare that as against what you've got. Yeah, that's the aspiration, isn't it?
So I think the ideal way forward would be to combine it with the data we've already got.
Mm-hmm. So comparison and combination, you can put it like that. Data preparation. So straightforward to vary the approach to data preparation to see if this has any effect on measured values. So for, as an example, making measurements on displacement rather than velocity seismogram. So once you've got information, once you've got the data, then instruments can translate that as the individual person wants, can't they? Once you've got the data, what you do with it, a number of things.
Yes, it was to investigate how sensitive the results were to the data preparation method. So you recall we were measuring the amplitude at each frequency, so how variable that was to the shape, bandwidth and things.
But so once you've got the data, people can do different things. They have different points of interest, won't they?
Yes, it's just as some of it in time series and spectral analysis is quite sometimes a little bit of art and experience, and different experts have different views, have different favourites.
Yeah, good. Right, measurement methods then. The way in which the data are measured could lead to variations in the results found. So particularly we suggest trying methods other than multiple filter approach, trying different parameters within the multiple filter approach, changing window width, shape, etc., etc. That's something that either Professor Macbeth or Professor Tuckwell could do just as well as you, isn't it?
Yes. Okay. Any competent geophysicist?
Yeah, there's nothing particular.
Or time series specialist.
Exactly. There's nothing particular about it. There's nothing particular to you. And Professor Macbeth and Professor Tuckwell could do that, and I'm grateful for that. Inversion methods, then, more sophisticated inversion methods could be attempted, especially if more observations became available. That's something that is not necessary, but it'd be a nice to have, isn't it? If you could attempt it, science, all good.
Well, if you have the data, you could. This is possible work. This is. I think first you have to get the extra data, and then you can choose from this smorgasbord of possible options. But I'm sure there are others which we hadn't thought of.
Okay, extra data, choosing from the smorgasbord. All right. Next thing, use of synthetic seismograms, complicated geological model. Of course, that goes back to interest, doesn't it? They're not the particular interest to you, but with additional data that could be done.
This could actually be done with the existing data set.
But if you get additional data, you could do that as well.
Indeed.
Yeah. Use of frequency-dependent parameters, investigating how to update the safeguarding algorithm to use frequency-dependent Q and V values. Now, that's not something that the applicant is proposing, is it?
No, it isn't. But it's something that could be considered.
Could be. It's not something the applicant is considering, because that would be breaking the algorithm, wasn't it? Doing something very different. That's not what the applicant is proposing, at least.
So these further work was directed at the general problem of updating the safeguarding algorithm.
Absolutely. And then understanding uncertainties, well, that's a general point. Yes, of course. So that's the possible future work, which has developed a little bit from earlier iterations in your recognition. And I just want to test that, if we may, against the scope of works. So we need to go to CD 89, and I also need you to have a copy of the condition. It's not a point about planning law. I just want you to have it. So there's a question which I think is fair to ask to you. So I don't know whether you've got a copy of that. The version that was before the update was in Mr. Thompson's evidence, you recall. That's in his supplementary report, or alternatively the updated version if you have got that with the words in consultation with the MOD. Do you want to hand? That's absolutely fine. Yeah. I'm grateful for you getting that. The very obvious point I want to make at the outset, and you've been very clear about your lack of familiarity with scopes of works, and that's fine. That's a very straightforward answer. But the way the applicant is proposing the proposal to go forward is to have two things. One is a scope of works, but one is a scheme. Okay, so if you look at just the wording of the condition, you see that there is after a certain date, it's in square brackets for 12 months, whatever it is. There's a scheme to be submitted. Yep.
So I have 3.
Yes. It says within the square bracket 12 months of the date of this permission, a scheme. I'm told that there is, Mr. Campbell, you probably just heard that there on my sheet there's two. There's the original previously proposed condition, there's a proposed revision, and then there's a proposed revision from the 2nd of March. So I don't know, it's on the second page. It's a clean version, and it starts off with a little 1, and it says no later than 12 months from the date of issue. Do you have that?
I do.
Yeah. So you'll see no later than 12 months from the date of the issue of this consent, the developer should submit for approval in writing the planning authorities in consultation with the Ministry of Defence, that's the bit that was added, a scheme for the further investigation of the effects. And then full stop. The scheme shall be based on the Esdelmure array scope of works produced by the developer. See that?
Yes.
So the mechanism, very simply, is that there is a scope of works which we're going to discuss in a moment. That itself isn't the end of it. There can be changes made to that scope of works, and let's see where we get with that. But in any event, that is converted into a scheme, which is the thing that gets submitted to the local planning authority, which it will consider in consultation with the MOD. Do you see that in terms of the mechanics?
I can follow the sequence, but
Yeah.
I have no idea.
Well, it's important for this reason. I'm not going to take you any further into whether that's lawful or any of that. That's a matter for other witnesses. But it's this, and I think it goes to, given the answers you've already given, it goes to the heart of it. Because what you're looking for, it seems to me, Dr. Bowers, is a degree of specificity in the scope of works akin to a detailed scientific mandate, and you want everything nailed down, because that's the sort of scientist you are. Perhaps no criticism.
I think that's exactly where I was coming from. With basing my comments on what I would expect from a research proposal to do some work to get an outcome.
Absolutely, this is not a research proposal, and I think that may be the absolute heart of this debate. Why we're here, actually. So, the scope of works, this is a planning document. See, it's not a research proposal, we're not applying for funding or anything else. This is an indication of what is going to be done. There is an opportunity to change that, but there is also an opportunity to convert that into something more specific, if that's what was required for the scheme. So it's not just this is a once and for all shot. This is an articulation of the scope of works, which then needs to get converted into a scheme. So do you at least understand the mechanics? That's how the process would work.
I understand some of it. My understanding, and I guess maybe I interpret this the word in terms as a scientist.
Yes.
Is that it needs to be defined.
Yeah.
And for me, this doesn't seem to be defined.
Yeah, so I'll go. What you wanted, or what you seem to want, is an abstract for a piece of scientific research, isn't it? That's what you want, detailed to the point where you're used to seeing that scientific paper, something, I don't know, you might be able to apply for funding for, or whatever it is. That's the degree of detail you were looking for as a scientist.
So I'm not quite. So what I'm looking at here in the context is it's not like a blue skies research project definition. It would be a are people familiar with technical readiness levels? So okay, in technical readiness levels, so 1 is you've had an idea, 2 is you've found a few bits of data that support it. It goes through to 10, and 10 is you've gone through 7, which is the thing is ready for operations. You tested it, and then you go through 8, 9, the further developments and errors are refined, to 10, where you've got an operational system that's actually been working for years and you're really happy with it. Okay, so it seems to me, in the safeguarding algorithm perspective, that we've gone from kind of TRL 2 or 3 with the Styles algorithm, 2005. Then we've gained loads more experience and sophistication with the Xi work in 2014, and that's been working now for 5 years, 6 years in an operational sense, and we've learnt some more about what may or may not be correct with the worst case turbine model in terms of what's actually been built. And so to move that on, I was expecting kind of at least that level of definition to define how this is going to improve things and what the outcome would be.
I think we're at the heart of this. As I say, Dr. Bowers, it's not what this document's trying to do, and it'll be for planners to interpret that against planning law. And I just want to just to touch on what it does have to say. And you've said, and that's absolutely right to do so, more data is good, more science is good. You also said in your evidence in chief, and I took a note of this, in relation to using straight lines to measure amplitude. And your answer to that was, well, what you're trying to get at is an estimate of 1D representation of propagation beneath the array. Straight lines are useful for that in your attempt to estimate 1D, and using straight lines removes some of that uncertainty. That was the answer you gave in evidence in chief. Yeah? Yes. So immediately we can see what we're trying to do for the first time is to have site-specific straight line data provided. You can see that in section 1, can't you? So it ticks the box, got a straight line. That's a good thing, according to you.
So the first line is, that I understand is proposed, is going south. So I guess what I was struggling with is understanding why you would measure the attenuation along the path that isn't towards the proposed development. So I'm struggling to, well, as I said in supplement inquiry statement and other places, whereas the proposals loosely defined, but could be adapted and improved to take on experiments and analysis that would help improve the safeguarding idea that we've got now. I was struggling to see how it would apply directly to this development.
Just to unpack that a little bit, one of the frustrations has been the length of time. You may not agree with this, but certainly from the applicant side, the amount of time it takes to get response from the MOD, feeling of lack of engagement and so on. If you've seen this scope of works, where can I find constructive comments about how it might be improved to include what you want? Where would I see that?
I don't believe they've been produced.
You haven't done it, have you? I mean, let's be fair. The MOD has not engaged with this scope of works to say this is actually going to make it better.
I can't speak for the MOD.
Well, well, MOD, I'm using loosely, Dr. Bars, you haven't engaged, have you? You have not helped to, in your, what would be in your view, improve the scope of works. You've simply not responded.
Correct.
Correct.
I've not been asked to.
Okay. I'll ask you now to try and help the reporter metaphorically take a pen. What would you do to help improve section 1? You see what's proposed by eminent scientists on this side of the room is what they say will give ample data for robust findings. That's what they say. What would you do to improve this?
Well, I think what would help would be an explanation of that why that configuration is like that.
That's I'm not going to stop, but that's going back, isn't it, to the science and your need to understand. This is about survey effort. This is about how or acquisition of further data, right? Let me ask you. Let me just step half a step back. What extent do you devise field experiments, and what experience have you got of doing that?
So I've never not been the chief investigation, but certainly I regularly review proposals to do field trials.
Yeah,
seismic deployments.
So in terms of devising field trials, So Professor Stars, you've got Professor Tutwell who do this all the time, right? This is what they've come up with. And they say, absolutely, this is what you'll get. Robust data set. Professor Macbeth says, yeah, absolutely, that'll give me what I need, right? So set against that, what I think you're saying is I review what other people have done, but you don't have any experience of actually devising the field trials themselves. Is that right?
So I have experience of designing field trials. I helped design the field trial that Craig Wind farm, and with consultation with design engineering, we developed that methodology from that they used the phase 4 deployment, and we've refined it over the years. That's not to measure attenuation, that's to estimate the source term. In terms of attenuation, no, I have not designed an experiment, but I have reviewed some that have.
So that's set against some case. It's not top trumps, but you set against two professors that do it all the time, who do devise these sorts of models or these sorts of field experiments for attenuation. That's fair, isn't it, in terms of the balance of experience?
So if I'm reviewing it, then I need to understand how each element of it works.
Okay.
So for example, we have explosions that are very close to the seismic sensors, and we heard from Professor Tutwell and Macbeth that you needed a certain offset before the surface wave became isolated from the body waves, and you could make the measurements that you need. It seems to me that the explosions are way too close to where the sensors are in a lot of these profiles. So I'd like an explanation as to how that works, because I don't understand it. So it's the offset, I think. So we see in the trial we've done with the temporary deployments with ABC that A was 2.4 kilometers from the blast, and that just about worked. But these are a lot closer, so I'd like to understand why.
Want to look at this?
If I was asked to do that by my employer, then
well, presumably your employer wants to be collaborative, constructive, and helpful. Presumably. Or does it not? Maybe it doesn't.
I might presume that too. But I think the interesting part is the resource. So it's priorities. I have a day job. I'm not dedicated to this unless it's explained to me that it is my priority.
Okay.
If I can leave it that way, I can't really tell you what my priorities will be in the future.
Well, where we get to is this. We've got eminent professors on this side saying these 4 temporary arrays are going to produce data to give robust findings to the satisfaction of them. That's what they say. If you thought there was something that you might improve on, then that could be communicated, couldn't it? If you were allowed to, had the time to.
Oh, absolutely. Good. But before that would be there would need to be a dialogue, and it's been said that a collaborative approach.
Yeah. Why hasn't that taken place in the 18 months that we've had? See, there's been a call, hasn't there, for constructive collaboration from our side. Why, is that just because you've not been permitted to, or why? Because you seem to now say, well, that would be a good idea to be collaborative and get on, but that's not been the messaging.
It's not what I've been asked to do in terms of the priorities.
So what have you been asked to do? Is that to say no? Is that been the instruction?
No, that hasn't been the instruction.
What do you mean by your last answer then?
The instruction was to go work and do the day job. So working group B was in August. And there's one in a couple of weeks that I need to prepare for. And there are other tasks that need doing, and this one wasn't on the list.
Right, that's absolutely fine. You're no criticism. You're a busy man, but what I take from that, you've got your list of things to do. But in terms of your employment, this hasn't been prioritised, has it?
But I had a quick look, which is why I can answer some
Quick
examples.
look,
but that was the level of my engagement.
Quick look, level of engagement. That's super. Thank you. Right, then into the further parts of the document, so we can move on from section 1.2 first order determination. And we can take this fairly quickly. Is it going to be the same answer all the way through, that fundamentally you don't have a difficulty with what is being proposed, you just don't see the level of detail that you might expect for the abstract for a piece of scientific research that you would expect to see?
So that is certainly part of it. I think, Mom, what I don't see is the expected outcome. What each element of this would bring to improving the safeguarding algorithm.
Well, it's very clear, isn't it? Mr. Thompson told you that yesterday. What we're seeking to do for the propagation term is to see whether or not there is validation. You've got Professor Macbeth's view about Q being 10, and you are there looking for data which would allow new values for Q and V to be slotted into the existing algorithm. We'll come on to the variation to source terms. I know that's important to you. And ultimately, that will be tested against the existing budget. What more do you need?
Well, it comes down to understanding the approach. For example, on the 1.3.1, I have no idea what the Schneider and Nole approach is. I can find no reference to that. So
that can be set out in the scheme, can't it? If that's what was required, and you say, what Schneider and that Nole, that needs to be set out, I can put in the scheme, can't it?
It's difficult. I don't know what that approach is.
No, I
no reference to it.
I get it, because I think, as I say, the third time I said it, it's right at the heart of this. Actually, I think you've just misunderstood, respectfully, what this scope of work is trying to do. It's not the document that you expect to see, but that's not what the planning system is looking for. However, the way the condition works is that there can be amendments to this. Be very helpful if the MOD did allow you. Obviously, it's a public forum. It would be very nice to know the MOD was going to allow you time to be collaborative. But if it didn't, then a scheme of works would be proposed to the LPA, who would consult with you, and they're required to consult with you. So at that stage, you could have your say. That's the very minimum. To put shortly, Dr. Bowers, you're looking for things in this document that aren't intended to be there. That's the problem. Right at the nub of this, isn't it?
As I say, I'm not really in a position to judge.
No,
I'm
thank you.
basing it on this TRL level,
All right.
the safeguarding algorithm forward. So.
That's very fair. It is. Let's just pick up a couple of other points, because the general point is good for all of this. I don't need to go through every section because it'll be the same answer. But algorithm reconciliation section 3, 3.2.5, 3.2.6, 3.2.7. So the extent to which the revised values of Q and V affect the source term, which has a weaker dependence on these parameters compared to the propagation term, will be evaluated. Based on the evaluation need for recalculation of the source term will be determined. Algorithm amended shall then be updated to reflect the updated values for Q. So that concern, I know what you're going to say, that doesn't have it in the detail and it's not set out, I'd like to see it. But that concern that was raised is covered, isn't it, in the scope of works? There's a recognition, quite right, that would need to be looked at. Doesn't tell you exactly how to do it, doesn't tell you exactly, but what it does do is say in the scope of works that would be done, and that would be corrected, or that would be picked up in the scheme. You get a chance to be consulted on it, and that would be done, wouldn't it?
Yeah, I mean, as I say, these are kind of so loosely defined, it's difficult to know how to measure the outcome.
All right, but now you know
point.
it might not need to be in here as long as it's covered. The topic is covered. Then we can see that it is, isn't it? So you've got your concern. It's an impact on soils, great. So that can be picked up and will be dealt with in the scheme, which you get a chance to be consulted on that. Nothing is going to happen until that is dealt with. Do you agree?
If that is the outcome, of course, I will try to act as asked by
Absolutely.
my employer as a scientific advisor.
Well, exactly, but it's important because the mechanics of this, and it's going back to the conditions. You've got scope of works, got a scheme, nothing's happened unless it gets discharged. So if that's a concern that you've got, that gets picked up, and the scheme has to be based on this scope of works. And if the scope of works tells the scientists that they've got to reflect the updated values in the source term, that will be done, won't it? You won't get the condition discharged unless that is done.
I can't comment on the mechanics of the planet.
Okay, that's fair. In which case, I'm going to suggest, and I've been going for an hour and 20 minutes, that we just take a short break. When I come back, there's a sort of miscellany of questions I'm going to ask on various points, Dr. Bowles, but that's very helpful. Thank you.
Okay, if we can just take a short break until 25 to 3, please. Thank you.
Right, Dr. Bowles, we've got about 45 minutes to an hour out of thought, and this is going to be a miscellany of questions that I think I need to put to you, so no particular order. I'm going to start with Q and the seminal work from Professor Macbeth, so CD 025. And I want to pick up this point about the Evans PhD, because your advocate seems to make something of this, and you've been taken to that document. And the simple point is this. You heard Professor Macbeth explain who, or his relationship and knowledge of that Evans work to be, didn't you? You heard him say, I knew about it, took it into account. You heard him say that.
I don't recall it, but
all right, well, let's
take your word for it.
We can see from the document itself, so internal page 789. So I think it's from that's the journal pagination in the top right hand corner. You can see acknowledgements and then the references.
So can you give me the page number again, please?
So there are actually 2 page numbers on page I'm looking at, but top right is 789. It's the last page.
Oh. Yeah, I see Evans.
Yeah, that's his 81 paper, isn't it? So
yeah.
that's propagation, dissipation of VHF Rayleigh waves in Scotland. So the thesis that you have been taken to was one of the source documents for Professor Macbeth's work, wasn't it?
Indeed, I understand he used the processed data.
Yeah,
from Evans's thesis.
And we can pick up the references if you want in the document, we can see at page 759 where there's the introduction to Rayleigh wave data and processing. You can see there's an introduction to the data. And then 2.2, the amplitude spectra. And then over the page, 760 underneath the table, you can see a healthy reference to the Evans work, all aspects of this, and subsequent data processing for high frequency Rayleigh waves are detailed in the Evans 81 paper. You can see that, yeah? And then Macbeth and Burton from 85 and 86. There are a number of other references to Evans in this document. We don't need to go to them all. That will do. Safe to say, probably just before the conclusions section. So that's internal page 787. So we'll see single station attenuation coefficients computed at each station using the single event station models. These are compared in figure 22 with the multi-station attenuation coefficients for the Carboniferous and Old Red Sandstone formations which dominate the Midland Valley, derived from the profiles of Evans. Okay. Yeah. So any suggestion, I don't know whether that was being made, but that somehow the work from Evans wasn't known or somehow contradicts the work from Professor Macbeth simply isn't right, isn't it? Professor Macbeth was fully aware of what was going on and indeed used it.
So, Mom, I have to confess a confusion. Yeah. So, figure 22 shows the attenuation coefficient. Correct? On the vertical axis. Okay, so it's coming up with values of around 0.1 for the C is the Carboniferous and O is the Old Red Sandstone at around between 1 and 2 hertz there. Now, if we go to the analysis Dr. Selby and I did in our 2023 report, CD 14.080, and we look at our figure 8, we find attenuation coefficients of around, well, just below 0.1. So that leads me to conclude that the attenuation is similar, slightly higher for the Carboniferous and slightly lower for the Old Red Sandstone than we're seeing under Estone.
Not the question I'm asking. Dr. Bowers, very interesting. The point I'm making is that it seems to have been suggested, well, look, somehow the work done by Evans in this PhD bypass what Professor Macbeth's got to say is support for a high value. That's been the way it's put. And I just want to suggest to you, through use of this document, that Professor Macbeth is absolutely aware of what Evans has got to say and used it and is aware of it, and it's nothing of the like, is it?
So the citation in the Heriot-Watt report per Evans gives Q of 7 for the Carboniferous and 9 for the Old Red Sandstone. Those values are not consistent with the attenuation coefficient numbers in figure 22.
I'm not going to cross-examine in the Heriot-Watt report. You can make a point if you want to through your advocate later on.
With respect, Madam Reporter, the witness was simply trying his best to answer the question put to him.
Yes, exactly. I said I'm not going to cross-examine in the Heriot-Watt report, so I'll leave it there. Thank you. Dr. Bowers. Right, next point. So we can put the Evans point away. Let's go to derivation of the value of Q, and we are probably familiar enough with the STARS report of 2005 to know that the parameter, it's on page 86. We know that in 2005, if anybody wants to look it up, and can see the answer or the assumption that was made, page 86, can't we? So that's the STARS report 2005.
I can see under parameters. Is this the...
Yeah.
Okay.
Yeah. So that's where that came from, and we know, don't we, that was drawn from the work of Professor Babette.
So, Ma'am, the value of 50 came originally from my analysis, rough analysis, admittedly, of that Jaguar crash data across the red line, red 1 to red 7, assuming a group speed of 2. So I calculated the attenuation coefficient, effectively, and backed out Q. And then we were looking, I think, for some peer-reviewed numbers that would support that view, and being unaware at the time of the Evans work, where she'd actually done it, and came up with a remarkably similar number. We found the Macbeth and Burton 1987 report and found there were these range of Q values between 50 and 11, which again is not consistent with the cited values in the Heriot-Watt report.
Mm-hmm. Now, what Professor Stiles has to tell us about that, now it's in a report, he's not here, and of course your advocate can make comments about weight to be attached to written evidence that hasn't been subject to cross-examination. Of course you can do that, but let's have a look at what Professor Stiles has to say about the history, and we can see that from the inquiry report, which is at APP 01003. So that's the inquiry report of Professor Stiles. See that? And it's page 3. It's page 11 and 3.7 that I'm interested in. You have that?
I have it.
Yeah, so value of Q was decided by Dr. Bowers of AWE at a value of 50 and then communicated to me by email. I understood from discussions with Dr. Bowers at the time that this was informed by an important paper on the seismic characterizations of high-frequency seismic waves in Scotland by Macbeth and Burton. That's the paper we've looked at, isn't it? 14025. That's the... Indeed. Yeah. Already familiar, or very familiar with the work of Doctors Macbeth and Burton, their classic 87 paper analysing data from large field interpreted requirements on Rayleigh waves. And then he says this, while a value of 50 was allotted for Q by Dr. Bowers and used in my budget tool, it should be appreciated that Macbeth and Burton also reported values 11, 25 and 100 depending on depth. The choice made by Dr. Bowers at the time seemed reasonable and would in any case err towards additional protection for EKA from the interference from extraneous noise on the conservative side. I think what you just said is that you had a quick look at it, and 50 gained some support from being at the high end of the range from the Macbeth and Burton paper.
So what I said was that we'd estimated Q at the array using the Jaguar data. Mm-hmm. This is noted in the preliminary recommendations to the Estelmio working group. That's CD 14.073. And that we were looking for a published corroboration that was a reasonable value. and we found this range of values in Macbeth and Burton, albeit I accepted it was for the Midland Valley, not for the lower Paleozoic rocks where the array is. And I would expect the lower Paleozoic rocks being much older, much harder, that Q could be higher than 50 indeed. But a Q of 50 seemed a reasonable number.
Over the page in what Professor Stiles has to say, 3.9, so the values for Q and V in respect of the UK were documented in the Stiles report and Bowers 2004. And figure 1 below clearly indicates that value for the propagation parameters Q and 50, V at 2 kilometres per second. And as far as I'm aware, there was no site-specific research that was carried out at the time to refine the estimates of Q and V. You agree with that?
Yeah.
The end of 3.9.
So as far as I'm aware, well, I am aware that we had the Jaguar crash data used to determine that Q of 50, and it's in this preliminary recommendations to SDMO working group dated December 2004, signed from Professor Stiles.
Yes, that's not site-specific research, so is it?
The Jaguar crash recorded by the... Sorry, Pridgeon.
Well, you know the criticisms that are made. You might not accept them, but criticisms are made from our side in relation to that. But leave that debate aside. Let's just get to perhaps the more important point. The value of Q, I think the technical term is ansatz, isn't it? It's something that's required to get the equation going. So you need a starting point. That value was never sacrosanct, was it? It was never intended to be sacrosanct, and Professor Stiles is clear about it.
So, Mum, the value as we established, I think, that affects the propagation terms, the product QV. And so it's around 100 in the safeguarding algorithm. When I estimated it from the Jaguar crash, in the red line, the attenuation coefficient indicated a QV at around 100. We had evidence, which I think is in the Stiles report, that the RG phase speed across the array from Q's work in 1967 is around 2.5 kilometers a second, and we had estimates of around 1.6 kilometers a second for Lowland Valley. So we took being geophysicists, we made an educated guess and said it was 2, and that backed out Q of 50. But the important parameter is QV. So the important parameter, thing that's affecting the safeguarding algorithm is QV, which is 100.
Not my question, as you know, Dr. Bowers. That value, as Professor Stiles tells us, was something to get the ball rolling, wasn't it? It's never been intended to be sacrosanct at that value. Subject to revision, further research comes along, that was always susceptible to review.
Oh, as with any parameter in the safeguarding algorithm.
Absolutely. So, as with any parameter. So the way you would do that is a data-driven project. You gather data of the sort that's proposed in the scope of works. And if that, I know you don't agree, but actually if that gave you useful data, then that value of Q could be refined, couldn't it?
It could be refined, but I would note the work that Dr. Selby and I did, and reported in our 2023 notes, where we did use more data, use the explosion, Jaguar crash.
And the criticism that I'm not going to go to that necessarily, but it's not accepted. You've got Professor Tuckwell's criticisms of that, as you know. But the principle, which we've just agreed, all those parameters are for refinement, and that's exactly the sort of refinement that Professor Stiles himself is saying you should do through the scope of works captured in this inquiry, isn't it? So the guy that you relied on in 2005 is telling you that was never the holy cow and actually is subject to refinement.
So I agree it's subject to refinement. I don't believe it mentions the scope of works in this part of the report.
No, it doesn't, because the scope of works came later, but the principle is that it was never meant to be fixed. And if data comes along to demonstrate that can be refined all to the good, you can amend that parameter. I think that's what we agree on.
It is, and we have done that study.
There's disagreement over that, but what those on this side of the room are doing is saying, well, let's get absolutely more data, better data, site-specific data, let's have a look. That's what the purpose of the scope of works is, isn't it?
So Ma'am, the scope of works proposes a line to the south of the array, and the estimates that we've undertaken are in the vicinity of the array and under the footprint of the array.
Yeah, but you've got
further work for sure should incorporate all of the data. In my view.
Great, you can incorporate all of that. You've got a problem with the temporary array to the south. You've got three others. The purpose. You are going to end up on any basis with more site-specific data than you've ever had, aren't you? And if that leads to refinement downwards of the parameter Q, which is what Professor Stars is suggesting it will, that's in line with what he always envisages. It was never meant to be fixed forever, was it?
So I agree it can be refined. It's not clear that it should be refined downwards.
Okay, thank you. But data and further research would tell you whether it should be refined down or upwards. And of course, the risk is, absolutely, you heard, I think Professor Tuckwell used these words, the data's the data. If the applicant loses and it goes up, well, then they don't get their wind farm built. If it goes down, they do. That's science, isn't it?
That is science,
yeah.
and it's the science that Dr. Selby and I have conducted using the data.
Well, you know there's
in the vicinity of the array.
Well, you know there's disagreement over that. So back to the Styles report for a moment. There's a number of points we can pick up from this. 311. It must be noted that the 2014 algorithm uses precisely the same propagation terms, so Q and V, as those used in the noise budget tool. So that's important to recognise, isn't it? Whatever Xi were doing, they were still using the same propagation terms, Q and V, which were derived by Professor Stiles and based on the 87 Macbeth and Byrne paper.
So it's true, Ma'am, that they're using QV equals 100. It's based partly on the Macbeth and Burton paper. It's also based on a preliminary look at the Jaguar Flash data that I presented in my 2004 report.
Yep. And there's a reference in 3.11, there's a quote about the taken from the report saying clearly confirming the need to revisit the parameters. But I think whether or not you need to, where we are now is you've agreed with me that they can be refined. We've got the right data, got the right research, and the value didn't need to be fixed, or was never intended to be fixed. That's where we've got to, isn't it?
Well, I think it's more general than that, Ma'am. All of the parameters in the safeguarding algorithm can be revised.
Yeah.
If there's evidence to support it, and there's agreement, I would suggest, by the stakeholders, but this is another issue.
Well, it is, and it's an interesting one because that important stakeholder, has to want to take part, or indeed has to be allowed to take part. And there's an open invitation to do that. And scope of works, you can do that, as we've discussed. But I think what you said was the MOD hadn't allocated you any time, and what you'd done was have a quick look at the scope. That's the sum total of it, isn't it?
At this stage?
Yes,
I had a quick
at this stage. Thank you. I just wanted to make sure I hadn't got that incorrect. Good. I want to pick up on a point about, just from Professor Starr's report. Now, we're not taking a point about threshold. You know that. So don't anyone get excited. We are not seeking to change the threshold. But I do want to just ask about the Elliott report. So that's CD 14.070, and we need a finger in Professor Starr's report at page 24. So it's in the section setting acceptable thresholds. Do you have that? So section 5 of Professor Starr's report, there was a reference then to the Elliott report. So within that section, we have a subheading. So threshold values, and then over the page on page 24, we can see subsequent to the above analysis, I was then provided with a value of 0.336 nanometers, which became the threshold for the noise budget tool, provided to me by an email from David Bowers, 17th of February 2005, without entering into any discussion as to its appropriateness, as a matter of expediency to some extent, but also because I believe then that AW had carried out the relevant studies and knew most about background vibration levels at the stations. However, this had been backed up by continuous reference to a report by Elliott, as that's the 070 reference, a preliminary analysis of RMS noise to EKS frequencies, etc., etc. However, the MOD is now advised that this work was undertaken as part of a summer student placement. No final report was ever issued. Just to stop there, when you look at the Elliott reports, not only is that part of summer student work, there's no reference in that document, is there, to a 0.336 budget?
Correct.
Yeah. So, in your 2013 report, let's just take a general point. We'll go to that document if we need to. General point. The whole basis, as I repeat, we're not seeking to amend the threshold, but just interested. There are people listening to it. That 0.336 budget, the MOD has had people believe came from a report, when in fact it was a summer placement student's work, and the report itself didn't reference that value. That's right, isn't it?
So it's correct, that it didn't reference the value. However, the data set, as I explained earlier, was used to determine the threshold based on the median value of windy parameters that were parameters measured at windy times in John Elliott's work that summer.
Do you know why? Maybe you don't, it's not for you, just say. Do you know why there hasn't been transparency over the origins of the 0.336 budget?
It's clear from the STARS 2005 report where it came from. As the histogram is plotted.
So if there have been suggestions from the MOD that emanated from the Elliott report, there would need to have been a caveat, wouldn't there? That actually was a summer placement bit of work, not peer reviewed. In fact, the value didn't appear in that work. And that isn't the case, is it? That's not the way that threshold value is being presented.
So the value 0.336 it explains that the data came from the Elliott study. Mm-hmm. It was a draft report. It may say in prep, I can't recall.
Can you speak up a bit?
Sure. So figure 64 in the STARS 2005 report is the histogram, which is the data taken from the Elliott study that I spoke to earlier at figure 33 in his report. And it's outlined in the email that I sent to Professor Starrs in February 2005, where also I should add makes clear that it's a summer student. So that is produced somewhere.
Well, let me leave that there.
No, I think we should. Well,
No,
up to you.
I've asked you a question. I put some fairly robust points to you, so I'm sure those listening will be interested in your answer.
Well, no, that's fine. Oh, it's at something.
It would be helpful for me to have the reference.
Okay, so it's app 01014. So that was where this histogram was attached to that email to Professor Starr.
Okay. Is there anything else you want to add?
I'm fine.
Okay, good. Thank you. The next question relates to a realization that the Styles model needed to be reworked. And you're aware, aren't you, that there was an outline proposal of work for refinement of the wind farm budget allocation from Professor Styles, which is in the papers at APP, so it's an app document 01070, it's 2009. You aware of that?
Oh, yeah. Well, okay.
Yeah, because Professor Styles was concerned, wasn't he, about the over-conservatism in the talk. What he actually tells us, if you want a reference in that document, it's on the, unfortunately, there are no page numbers. So it is about 4 pages in to that document. It's difficult if you're in a PDF because it'll probably be about 8 or 9 pages in, I suspect. But there's a paragraph just above some plots with a paragraph headed "Little Additional Work."
Mr. Hardy, can you phrase your questions clearly? So what you're making it clear what you're asking.
Yes.
Dr. Bowers, you're making lots of statements,
yes.
But then that's leaving Dr. Bowers be thinking, well, what am I actually being asked
yes.
here, I think,
so we're going
from my understanding. So what are you asking?
So we need to go to that document. The first point is on a page which hasn't got a page number on it, but is above a plot, and it is a paragraph headed "Little," or starts with "Little."
The little additional
Yes,
work.
that's it. Yeah,
I have it.
So, as recorded here, Professor Styles was of the view that little additional work had been done since that work from the Kiel Group, 1996, and then Stars in 2005. Do you agree with that?
Yes, it was pioneering work.
Absolutely. And this was an outline proposal put forward by Professor Styles, which didn't get taken forward.
Correct.
But what it does do is indicate a concern about in the absence of further work, a concern on the part of Professor Styles about the over-conservatism in the talk.
So I think the proposal was to revalidate the algorithm, given that the technology that was measured had done more, which were getting pretty old wind turbines there, might call fixed speed, so they're not modern turbines that are pitch regulated.
Yep.
I've learned from my engineering friends. So the scientific point was, well, the turbines that are being built are not the same as the ones that were measured back in 2004. And some of these studies, the Fiori study, for example, showed different spectra. And there was, it was the Estelmuir working group, or maybe stakeholders, where this was proposed, but there was no funding to take this forward.
Okay, but that's an indication of concern about the need to look again, isn't it? So the author of the report was saying, actually, we need to do this. Here's a proposal that wasn't taken forward.
I agree. Okay. It was to look again, to revalidate, rework the algorithm as it was in 2005.
Okay. As a more general point, there's no dispute, is there, between us that the algorithm as it has been used is overly conservative, actually to quite a high degree.
So the degree has been quantified in the phase 4 report of the design engineering. That refers to the source term. And that work, as I've said, was undertaken to identify any potential headroom in what's called the budget threshold. But what has not been discussed is how that work might feed into changes to the safeguarding algorithm. That is still in my inbox.
Yes. And we can see from the Xi report that the authors of that report say conservatism built in at pretty much every stage. That's their view, isn't it?
In terms of the source term, that is a fair statement. That is my conclusion. Yeah, but only in the source term.
Okay. Thank you. And that it's a policy matter. Don't need you to answer, or if it's not for you, just say. But the government picked that up, don't they? Have you seen the policy statements from the government, most recent ones, NPF4 and the onshore wind policy statement? If you haven't, I'll pick that up with others. Right? Okay, fine.
I think I was sent an attachment, but I haven't read it.
Don't worry. I'll pick that up with others. Okay, utilisation factor. The approach adopted by the MOD following the Stiles report was that aggregate noise output from the operating wind farms in the consultation zone could exceed the 0.336 threshold for 20% of the time.
So it depends. It's a poorly worded sentence in the Stiles report, which I believe is open to more than one interpretation.
Okay.
My interpretation of this is that if the threshold is met in the safeguarding algorithm, okay, so the prediction hits the threshold, then 20% of the time, on average, the threshold would be met. But because the wind turbines are treated as random noise, the actual vibration of the array could be greater than or less than that threshold.
All right. That interpretation is not shared, is it, by everyone? I think you're very fair. That's your interpretation of what it means.
I'm not sure you can include any other interpretation.
Well, you said it was open to interpretation. Are you?
Well, I said it was ambiguous the way it was worded, but when you look at how the calculation was done, that's clearly what it means.
What Professor Stiles did, so going back to, I think it's figure 66 of the Stiles report. Do you have that?
Indeed.
That identified that production exceeded 60% for 20% of the time, didn't it?
For those 4 wind turbines.
Yes.
On aggregate.
Yes. And as a result of that, the original algorithm was discounted, wasn't it? So there was a 60% utilization factor adopted for the model noise output.
It was.
If you then move forward to the Xi algorithm, so the 2014, so section 6 of the 2014 Xi report. And that's CD 14.004. That algorithm assumes that to occur 100% of the time, doesn't it?
No.
Well, I'll put the proposition to you that is assumed to occur 100% of the time based on aggregated met mass data and the generic candidate turbine being installed at every location across the consultation zone. That's the proposition.
No. The calculation that was done says that 20% of the time, 82% or greater of the total rated power would be generated.
So there may be a dispute then about that point, because Professor Stiles in his work says, well, look, that algorithm currently assumes that all turbines in the consultation zone will be operating at rated capacity all of the time. That's the proposition.
That's not what section 6 or the prevailing report says.
All right. Well, there is a debate about that, and that maybe can't resolve that. Professor Stiles is not here. But let me ask you a practical question. You heard Mr. Thompson had to say, in terms of somebody that operates a wind farm, maybe even common sense. Turbines do not operate at 100% capacity all of the time, do they?
I completely accept that. Yeah.
And if an assumption was made that they do, that would be a considerable over calculation, wouldn't it? If that assumption was being made.
But that assumption is not being made.
There's a dispute about that, but if it was, on the assumption, on the hypothesis that it was, then that would be an over exaggeration, wouldn't it?
Well, it's a hypothesis.
Mm-hmm. And we can see that one of the things that the scope of work, so back to CD, if you want to go back to CD 14.089, and internal page 8, section 2,
I'm sorry, can you repeat the...
Yes, so that's back to the... Yes, it has, and we're going to come to a close soon. Dr. Baz, you've had a long day. Section 2 of the scope of works, it's CD 14.089, section 2. Have that?
Okay, yes.
So 2.1.3, the topic, the proposal is to recalculate the utilisation factor based on actual production data for wind turbines currently operating in the consultation zone by reference to the mean of their normalised production curve. So the 20% exceedance intersection can then be identified, and there's a process which is given below. That's a good idea, isn't it? Because you're looking at real world, and that's important.
So my understanding from, and Mum, I'm not an expert on this, but my understanding is that the anemometry data of the mast is a reliable way of estimating the electrical power output from a wind farm. And they've used 14 well-calibrated measurements, instruments, these anemometers, and they estimated that at 20% of the time, 0.82 is estimated as the definition. Now, as I go on, as I mentioned before, to say that this actually isn't quite what you want, and further work is needed to understand the length scale, how the wind speed varies close to the array versus far away from the array, because it's the turbines that are closest to the array that will have the greatest impact. And that further work does not appear to be captured in this scope of work.
Could be, if you wanted to add that, but the idea at a high level, or a higher level, is that real world utilisation, the way that turbines operate, is going to demonstrate, I mean, you've agreed it anyway, it's common sense, they don't operate at full power 100% of the time. So looking at real life data is a good thing, isn't it, in terms of the tool?
So the definition of the utilisation was operating at some proportion of rated power 20% of the time, not all of the time, in terms of the impact on the array. And clearly more data is good, but I really think the further work noted by Zion outlined needs to be done before any utilisation factor can be considered in the algorithm. It's currently set to 1, so it has no effect, but until that's considered, this further work really does need to be done. And there was a proposal to use the prevailing data sets could be repurposed to do that. So there was a methodology. I think there's still some further thinking on how you estimate this correlation length. And if I were to cooperate on that, I suspect I would end up working with weather forecasters and numerical weather models and wind speed experts in your area. But that's where that expertise needs to come from.
And is that something you're minded to do?
If instructed.
If instructed.
Have it go.
All right. We've dealt with the source or calculations of the source term. I think that's headed under the algorithm reconciliations under 3.2.7. 3.2.6, 3.2.7. I don't really need to go there. Right, last point. Pick up the Xi report, which was interesting, the 2014 one. It's a good point to look at this conservatism issue. So that's at CD 14.004. And it's section 10, internal page 95. You can see in the discussion there, conservative approach used to design the physics-based algorithm to ensure it protects the detection capabilities of EKA. The algorithm produces a spectrum to represent any wind turbine based on its rotor diameter and hub height. The representative spectrum combines the following worst-case scenarios, and we've got constants in the physics-based algorithm selected such they were always over fit all peaks related to blade pass and second bending mode. Power in the peak related to second bending mode. Far field seismic vibrations from turbines examined tend to be either dominated by blade pass. Fixed-based algorithm uses both blade pass multiples and structural resonances, and constants used for the blade pass components were largely dependent on their fixed data, sensor downwind, blah blah blah. These successive levels of conservatism build in significant safety into the physics-based algorithm such that no additional factor of safety is required. So that's useful capturing, isn't it, of what Zai was saying in 2014 about the algorithm. Yes? Okay. Thank you. Let me just check my notes. Dr. Bowers. Just one other matter, and that's from your 23 technical note. Just put that up. And just a point of clarification, so CD 14.080, so that's the technical note, and we can take it in the summary really, that the third paragraph down on the summary, so to do with their frequency, since the current algorithm assumes that Q and V are not frequency dependent, and the majority of the SGV power predicted at the arrays in the 1.5 to 4.5 Hertz band, we find the results presented here do not require any change to the Q and V values in the existing algorithm. The point really is that in terms of frequency, that band 1.5 to 4.5 is a primary interest, isn't it?
So, with the frequency distance weighting function, or the propagation term times the receptive term, that is the response for developments about 15 kilometers away and further. To get a bit closer, then you get a little bit of power predicted. I think it was 17% of the power was above 4.5 Hertz from a typical turbine at 4.7.
Okay, that's helpful. I don't need to go into that any further. I don't think. Right, good. Thank you very much. That's all I want to ask you, Dr. Varston.
Dr. Baz, I don't have any questions for you, but just wonder if you need a short break, or how long do you think you have in terms of re-examining your witness, Ms. Crawford?
I have one question which may lead to a follow-on question, but it's a very short topic.
Do you want to proceed? That's fine.
I think I'll ask Dr. Bowers, if I may. He's the one who's been having to concentrate fully. I don't expect to be longer, as I say, than the one question, but Dr. Bowers may wish a short break.
Do you need a short break, or are you happy to carry on?
Give me 2 minutes, I'll come back.
All right.
Yeah, okay. Just a few minutes. Yeah, no problem.
Good afternoon, Dr. Bowers. As headlined just before we had that short break, I only really have one question which I'd wish to your comment on. And for that question, could you have again the scope of works before you, CD 14.089? And I think you also were handed a hard copy of the proposed revised condition. And again, if you could have that before you.
Yes.
And could I ask you this? If you were instructed, whether by the MOD or indeed by Dumfries and Galloway Council and Borders Council, on whether a scheme based on the scope of works we've looked at was sufficient to enable you to advise on the impact of fossil on the array from seismic ground vibration, what would your response be?
There would have to be much more detail in the draft scope of works for me to assess that, and I would need some, I think, guidance on what the criteria would be. An example would probably be helpful.
So somebody picks up the phone and says, Dr. Bowers, we've got this scheme. Can you tell us if that's going to enable us to assess the impact of Fosside wind farm on the array Estill-Muir?
So it'd need much more detail to make that judgment, if that is what I'm being asked to do.
Okay, thank you very much.
I guess it's for others to decide what that level of detail is, but for me, there isn't sufficient detail to make that judgment.
All right, thank you very much. I have no further questions of Dr. Bowers.
Thank you, Dr. Bowers. I'm just wondering if it'd be worth just a quick comfort break for everybody now in the room. It's gone really warm in here now from being very cold. We're from one extreme to the other. That might be quite a good idea. And then we will pick up the next witness.
Spoken outside, you probably saw that. I think we're going to switch well, it's not for me, but my own friends indicated you're going to switch the order. So it's going to be Mr. Laws next, and then it'll be Mr. Egan. And I can indicate that I don't think it's going to be very long in chief, and it's not going to be very long in cross-examination of Mr. Laws. So.
Is it the intention then that we might get through that today?
Yes.
Ms. Crawford?
This is why I had a discussion with Mr. Harvey. It has been a very long day, a lot of technical information. You, ma'am, have had to consider a lot of technical evidence. The intention was, still probably is, to finish today, but I do wonder whether that's realistic. So far as Dr. Laws is concerned, I can say at the outset I've nothing to ask him in chief and simply invite him to adopt his reports, etc. I anticipate there'll be little cross-examination. Mr. Egan, there is a bit more material to cover, and I do wonder whether whether it would be to the detriment of this inquiry proceeding when we're all tired at, say, 4 o'clock with Mr. Egan's evidence. Another alternative is to see what time it is when we finish Mr. Laws and take it from there. But I am concerned that it's been a long day for all of us, and I'm concerned that you have the best evidence and it's given in the most efficient and effective way.
Okay, happy to see where we get with Mr. Laws, but I will keep a decision about Mr. Egan until we're at that point. But I hear what you're saying. It has been a very long day, and we are scheduled to have another witness tomorrow, so I'm happy to run it into tomorrow if I feel that's appropriate. Okay, so we'll just have a break just now. We will come back in 15 minutes. So it says 3:38, so we'll come back at 5 to. Okay, welcome back, everybody. We'll make a start with the next witness. The next witness is Mr. Stephen Laws on behalf of the Ministry of Defence. Ms. Crawford, do you want to introduce your witness?
Thank you, ma'am. Good afternoon, Mr. Laws. Mr. Laws, you have prepared for this inquiry an inquiry report, a precognition originally drafted for the original session, plus a summary of that precognition, and a very short supplementary precognition for this session of the inquiry. In your inquiry report, which is a CD 14.062, you explain that you are employed by the Ministry of Defence, specifically the Defence Nuclear Organisation, DNO, and that you've been employed by the MOD for 31 years. Is that correct?
That is correct.
And you then, in section 2 of your report, explain the role of the DNO, and you tell the inquiry that it oversees work which is undertaken by the Atomic Weapons Establishment, AWE, about which we've heard something, an arm's length body of the MOD, and that you are a DNO project officer within a programme called Nuclear Threat Reduction, which includes the requirement for nuclear test monitoring capability within the UK. Part of that programme includes contracting AWE for the provision of facilities and technical expertise in support of the United Kingdom's obligations under the signed and ratified Comprehensive Nuclear Test Ban Treaty. Instructions provided by DNO to AWE include the maintenance, upkeep and monitoring of the UK seismological array at Eskilmuir. Does that properly explain the role of the DNO?
That properly explains my role within the DNO.
Yeah. And you then tell us something about AWE Black Nest, and its main functions in section 2.2 being to develop and maintain expertise in using seismic techniques to detect and identify underground explosions. And that has been employed in the past to provide assessments by the UK government on nuclear explosions carried out by other countries, and as part of the UK's contribution to the CBCT.
Yes, that's correct.
And I needn't take to section 3, this is perhaps more relevant for the evidence from Mr. Des Egan, but this explains the part which the Defence Infrastructure Organisation plays. Is that correct?
That is correct.
Now, taking to that those two introductory sections of your report, and I outlined at the start that you provided a precognition, a summary of that precognition, and a supplementary precognition. Do you have those documents in front of you?
I do.
Are you content to adopt those as your evidence to this inquiry?
I am.
Is there anything you require to change or amend in relation to what's set out in those recognitions?
There would be one tiny amendment, and that would be on the number of signatories and ratifications to the CTBT, but that's immaterial to the proceedings today, I think.
For the sake of accuracy, would you wish to make that amendment?
No, I can look at that, making that amendment. Thank you.
Having listened to the evidence over the course of the last 3 days, is there anything you'd wish to add to what's set out in your report, precognition and supplementary precognition?
Nothing to add at this time, ma'am.
I have no further questions.
Thank you, Ms. Crawford. Mr. Hardy, do you have some questions for the witness?
I mean, very few, quite frankly. The statement of agreed matters. So also, we could just turn to that. So that's CD 14074. Got that? Yep. Did you play any part in the negotiation of that?
I was a party to its drafting, yes.
Thank you very much. So most of the points that are set out in your documents are dealt with here. Just one thing to alight on, 3.7. There's some suggestion about the applicant downplaying the importance of the array. I just want to look at that. 3.7 in the statement of agreed matters. You see that?
I do.
It's been common ground, hasn't it? That all along the MOD have advised that the array is the UK's primary asset. for monitoring underground nuclear tests. The applicant doesn't dispute the national and international importance of the array in relation to the UK's obligations under the treaty. So you've known, or your side of the room have known, that that has not been in dispute at all.
We have heard from the applicant's witnesses over the past few days, and as you say in the statement of agreed matters, that it is not disputed the national and international importance of this array.
Yeah.
I was referring in some supplementary, my supplementary recognition to the report by Professor Stiles, where he started to question auxiliary seismic versus primary seismic, which, as we have all effectively agreed on the international and national importance of the array, is largely irrelevant, I would suggest.
So we don't need to take that any further. Just one further point in relation to minor amendments or changes to the way the algorithm works and so on. They don't need to be ratified, do they, formally, or adopted by the higher organisation. They are what the responsibilities for the MOD is to make sure that the array detection isn't degraded. But beyond that, how it does that's a matter for it, isn't it?
It is our responsibility to maintain the array to the standards as defined in the operating manuals defined by the CTBTO.
Yeah. So, in other words, you've heard the evidence, and I don't think there's anything that we're disagreeing about. If the parameters were changed, but nevertheless that degree of detection is maintained, that's fine. It doesn't need to be signed off by the higher authority.
That is correct.
Thank you very much. That's all I want to ask you.
Mr. Laws, just a question here that you can maybe just elaborate a little bit on. You may have covered it in your inquiry report, but it's just, you say that the array makes it an unparalleled resource for forensic seismology. I just wanted you just to elaborate a little bit why it's unparalleled. What is it that is extremely important about it?
So the array was established in 1962, and since then it has been used by the UK to monitor the nuclear tests around the globe. It has compiled a unique data set in that respect that has largely validated the array, so that we now understand the array's characteristics and we can actually better characterize tests from predicted test sites. Does that make sense?
When you say understand it better, you can just elaborate a little bit if you can.
So if way back when they were doing above ground tests, when they were doing underground nuclear tests, there was a large number of testing being conducted around the globe, and the array detected those, and we have that data set. That data set has largely validated the array, so such that, given the sparsity of opportunities to calibrate it now, it is well calibrated from the testing in the past. So were a test to occur, it is well placed for us to be able to detect, locate and characterize that test. It's unparalleled in that since 1962 we have that data set, which is largely validated.
Thank you. No further questions. Ms. Crawford, do you have any follow-up questions?
No, thank you. Thank you. No.
Thank you, Mr. Laws. It's 4:05. I would suggest that we finish for today. I think that's a reasonable point in which to finish, rather than start with Mr. Egan. It's been quite a long day. We're scheduled to have another session tomorrow. So if we could all be here at 9:30 tomorrow, we'll take Mr. Egan, who's the final witness for the Ministry of Defence. Thank you.